right, so I think we can get started then. Welcome here in person and online, out in the internet. And welcome to the session, Docker for Web Development. And before I explain you who I am, and I will give you a quick introduction what we're about to do the next 4 hours, I will give you a little introduction about the course itself, tell you who I am, and I would like to know if you have any special expectations, or if you are here because of a very specific problem you're trying to solve, because this is something I have to know, right? Because then we can talk about it, we can switch a little bit in the agenda to make sure that I cover your questions. And anything else you would like to share before we get started, because it's important to me that I know what you want to do. I've prepared a couple of things, but if you have something special, just let me know. Then we'll make sure we will cover it. Yeah, after this agenda, basically housekeeping stuff, I give you a little introduction into Docker Desktop and why I think it's an important resource for development with Docker nowadays. Then I will give you an introduction in our project, high-level architecture and the software and the components we will use and what usually I use in my web development projects. And then we'll have the first coffee break, coffee, tea, bio break at 9 to 9:15. Then we will do actual development, setting up our project using Docker init to spin something up. And then we'll start with the backend development and create a NodeJS API and PHP API. And this depends on the questions you have. I think we are not here to learn how to create actual APIs in Node.js or PHP, or you can choose whatever language you want, Ruby or Java and Kotlin, whatever. So that's why it's a very simple hello world thing. If you have specific questions about how to do X, Y, Z in a specific language, let me know and I can try to answer that question. But it's not a programming course today. I'll give you some best practices I'm using in my projects, but that's basically what I want to do. Then we have another break before we are doing the final things, doing some front-end development using a ReactJS, and then we try to glue everything together, the APIs we have created, and basically the front end. And at the end, would like to get your feedback, and if there are open questions, we can answer them. So that's actually the plan for today. And before I get your question and what do you expect from today, would like to introduce myself. My name is Timo Stark. I'm from NGINX, working at the engineering team for NGINX, and I'm here as a Docker captain to deliver this workshop, but have like more than 12 years of experience with web development. That's what I do half of my life. That sounds crazy, but I'm 32 years old now, and I've started web development when I was 12. So that was basically, always my good love in development was something for the web. And I basically started with Docker back in 2017. That was my first DockerCon in Austin. And since then, I'm using Docker heavily, especially for my day-to-day dev jobs. When I'm not engineering at NGINX or doing Docker captain stuff, I'm doing some sysadmin site work, Linux server administration, or just hacking around on bug bounty programs and do some security stuff at the site as well. Right, so that is personally basically what I'm doing. And now I would like to if you have any expectations, like do you have anything to share why you are here, basically? Or do you have any questions, specific questions why you're here? If not, that's totally fine. But if you have something in mind, that would be good to know.
Yeah, so I'm speaking tomorrow at a similar topic, like Docker, desktop, web development, and observability and stuff.
Mm-hmm.
So I'm just here to take inspiration how you're setting it up, and just see like what devices.
Okay. Oh, amazing. Perfect. Yes? Okay, connecting Active Directory using Docker?
Yeah, we need to connect our Active Directory on our network.
Okay. Oh, okay, good point. So Just make it clear you have a Docker container and you spin this up, and then you can, from this Docker container, you cannot do an LDAP connection. Okay, good. Good point. We'll try to cover this a little bit so we can talk about Docker networking in general. Okay?
I'll just throw this out there. I work for a company that has a very large monolith/mono repo style, and just how best to package that.
All right. So if one application with a couple of services in it, and
Yeah. So we could split it into multiple containers, perhaps.
oh, okay,
The old orchestration.
perfect. So question here is what fits in a single container and what can be orchestrated in multiple containers. Okay, perfect. Thank you. Yes.
I'm moving a .NET 6 application into a web app. I want to put an API on it and then join it with an existing static website.
Okay, perfect. So it's most questions about packaging and basically how to use Docker containers and Docker files and to pack your and ship your applications. So that's definitely something we'll cover. Perfect. All right. Great. So next step is Docker Desktop. Let me just bring this thing up. And yeah, there is a neat trick. As Docker Desktop is fully web-based, I mean, we have this little thing, right? That is the wrapper application you can install. If you haven't already Docker Desktop installed yet, you can go to the Docker website and install it from the website. Is there anybody that needs to install Docker Desktop right now? Okay.
Just commenting the slides are a bit light. It's hard for me to see. I don't know what it is. Maybe it's a projector or something.
Yeah, it is. We have,
It's a bit light. It's like a bit dim.
right. Yeah, this one is better, but I've already tried to fix that, but it's can you see that okay? Is that, yeah? Otherwise, we have more seats here if that works better then. Sorry for that. Yeah.
Can we get to the live presentation at the same time?
I think so. The link was sent by email. I didn't receive any link. All right, so let me spin up a new thing here real quick. Right, if you go to, like there, we have docs, or the Docker people have docs about installing Docker Desktop on Windows and Mac and Linux, basically, like in Ubuntu server. And the interesting story about Docker Desktop in general is I haven't touched, not kidding, I haven't touched Docker Desktop since the early time of 2023, right? So that was, 2023 was actually the first year I have touched Docker Desktop at all. Because I've created the NGINX Docker Desktop extension, that was the main reason why I have touched Docker Desktop for the really first time. And like, I loved it after 2 hours of using it. I was always the CLI person working with the Docker CLI while doing development, no matter what I did. And after using Docker Desktop for just 2 hours, it was so much easier than just doing all this typing. Because you can get a lot of insights, and that's why I would like to show you a couple of tweaks, a couple of things, how to navigate in Docker Desktop. It's not really a session about Docker Desktop, but I just would like to give you a little walk through Docker Desktop, what you can actually do with it. All right, so as said, you can download it from the website. And ping here, install for Mac. Make sure you're using the right chipset, like Intel or the M2 chip, then, or on Windows. Then you can install it, launch it. So I'm using the latest stable version, which is 2.24. So then what you can do first is you can sign into your Docker Hub account, right? So if you sign into your Docker Hub account, this helps if you have some private images, for example, in the Docker registry. If you already signed into your Docker Hub account, you can pull them from your container registry on Docker Hub without typing in the password manually into the CLI. So then here on the navigation, you have the containers. And these are basically the containers that are currently up and running. And the neat thing with basically this overview is that we can pause a container, we can restart a container, we can delete it, but if you click on the container, you have basically the output, you can copy stuff to the clipboard, then you can directly execute in the container. So basically what you normally would do with Docker exec something. And the neat thing about this is, quick question, if you have launched a container from somewhere and you would like to execute something in the container, what you always can do is, let me make this a little bit bigger. Can you see that okay? Yeah, so we can type docker ps. And now, just imagine we would like to jump in the container and do something. So we can do docker exec et, and then you can use the name or the ID, but you don't have to specify the full ID, and that's a neat trick I'm always happy to share. As long as the ID is unique, you don't have to type the whole ID. If we have here just one container, I think, to me, I'm always using just the first three parts of the ID. That's totally enough. I would never type 2b, 3, dc, whatever. That's not necessary. So it's a waste of time. Don't do this. Docker exec space -it 2b3 is all we need. So and then, if you would like to jump in the container, we usually use bash, because it's a Debian-based image, it's CentOS, it's Ubuntu, it's something like this. Then enter, and this time we see this little error saying, hey, that's not working. Okay. In this case, I know because this Node.js thing is Alpine, and we don't have bash in Alpine per default. So we have sh in Alpine. Oh, that works. Perfect. Good. So in Docker Desktop, and that's why I love this thing, if you click on your containers, then if you click on your Node.js container, you can jump here, open the terminal. See, it just works. It knows it's Alpine. It knows that sh is in this case, the way to go. So it's not erroring. And you can do this in your web UI. You have a second monitor. You just pull it over, and you can navigate through your containers really, really easy, and can see the log output. You can see the inspect. Let me tell you 1 second about what does inspect mean. And if you're already familiar with things I'm saying, just let me know. Then we can jump over it. Docker inspect is basically printing all the metadata of the container, right? So why is that, for example, important? It will basically show you what ports are exposed, if you have files mounted to the container. This is something that will be shown in the inspect mode. And one thing I am most interested in when I do the inspect, we have this image SHA-256 hash. So this hash shows, okay, what is the exact version of the image I'm currently using? Because if you start developing with Docker a lot, and you type 100 times Docker build, not always, but sometimes you will see that a version you're pulling from a registry and you have on your development environment, like on your staging environment, for example, should be identical, but for whatever reason, you have a different behavior locally versus what's on staging. And then you can try half a day to find what are the difference, and sometimes this happens because you have the Docker tag latest, and I will come to this during the session absolutely, because this is for good and for bad if you always use latest as a tag to push new images to a registry. And if you have this kind of issue that the staging environment is doing something completely different from what you have locally, then it's sometimes important to check this image hash. You can check the hash online, and you can check the hash on your local machine. And if the image is totally identical, then the hash should match. If the hash is not matching, then you have local, a different image than on the staging environment, right? That could happen, for example, if you push an image with a tag latest to a registry, and then you have a tag latest on your machine, and then you pull, for example, an image from a registry, and in 99% of the cases, it will override the latest image. But there are some smaller cases where this is simply not happen. So it will say already the newest version, or somebody else pushed something to latest in the meantime from another computer. You pushed, and somebody else pushed, and you're not checking that the update was like overridden. So you have not the latest image. That sometimes, I mean, I came across this problem a couple of times, and that is just crazy. And to me, if I do some comparison between local and staging because I want to inspect some stuff in the image, I'm always checking if the hash matches. If the hash matches, fine. Then I can inspect and can look in the container and do stuff. Good. So that's basically what's in the inspect thing. You will not use that really, really often. But from time to time, it's useful to do the inspect mode. And yeah, another nice thing here is you can click basically on your anchor links to jump in this JSON output. If you do this on the CLI, you can do the same thing by Docker inspect, Docker PS, oops, not in the container. As said, Docker PS will print the running containers. And then, let me clear that. If we do Docker PS, we have an ID, and then we can do Docker inspect, and we get the same output. And then we can, of course, use JQ or grep or something to get to the point easily where we get this information. But it's just easier if you have a bunch of containers using Docker Desktop for that. All right, bind mount is something I will tell you in this workshop as well. What is a bind mount? It's basically mounting your local file system in a container. And before Docker Watch, little spoiler alert, because that's something we will see as well. Before Docker Watch, I've always used bind mounts for development. So what does a bind mount do actually? A bind mount is you have a directory on your computer. So at the moment, we are here in workspace, DockerCon 23. And then we have a dev workshop. And in the dev workshop, we have a bunch of directories, like backends and database and frontend and proxy and all this kind of things. And if I want to do some backend NodeJS development, for example, what you can see here is we do have the Docker file and another one and compose and node modules and package JSON and things like that. So and the bind mount is actually, when I now do Docker run, and I put v, as you can see, that's something different, but that works as well. So we use the current work directory, and we mount it to, let's say, I don't know, let's put user source for what it's worth. And then we use node as an image. Like, I don't want to download it because I think the network is not. So this is also something I can show you. This is now, you can see that is node. Where is node? I can try to find it here, and there should somewhere a Node.js image. I've already downloaded it. Node.js server. OK, that's Alpine, but that's fine. Let's use that one. So Node.js server. Yep. All right, that's great. So now another thing. You can use Docker images on your CLI to detect where your images are, or you can basically use here the image tag to see what are the images that are currently on the system. Is it 100% clear what an image is? A Docker image? Yeah, that's fine? OK. Where are we now? OK, now workspace. workshop. Okay, so. All right, so I would like to show you what the bind mount is, just to make sure. You can do this, docker run -v. Let's use an NGINX container, that's also fine. User, because it's not, we are not doing actually anything with it right now. We are basically just trying. Okay. Then we override the entry point. Right, so now we should see the user source. So we see all the data in here, like node modules, package JSON source. So when we do now, when we look in our Docker desktop and click on our image here in bind mounts, we can see, okay, we have mounted this directory to user source in the container. It's like literally like you mount a hard drive on a server. And we have some problems with it, and this is something I will tell you later when we look for the new Docker Compose watch features. Because now, anything we do inside of the container with the files we have just mounted in it will also represent it to the host automatically. There's not a copy. It's like literally a mount of your files in the container. Sometimes you need this, but it can also be very dangerous. And I shot myself in the foot 1,000,000 times with this method. Not kidding. So especially when you do something in a hurry and you would like to test something, and you mount something too quick in the container, and in the container you delete something and you go out and now it's gone. Oops. Not good. So, all right. Perfect. So this is a bind mount. This is what we can inspect here as well. Exec is what I've done 1,000,000 times right now, just doing this Docker exec thing. Why is that useful? Especially when it comes to development of web applications or applications in general. There is a process, or I have a process of developing Docker images or container images. You start from a base image, as always, from some base image. So, and then you have to do some things in your Docker file, like update if you have a Debian-based image, and then you install things, perfect, and then you do X, Y, Z to make it work. Okay, absolutely perfect. But how do you come to this point to know what I have to do, basically, in the Docker file? And I saw a couple of attempts from other people. They're writing a Docker file. Then they say Docker build, fails. OK, change the Docker file. Try Docker build again, it fails again. This works. Technically, this works, but it is inefficient as hell. I mean, you try Docker build 1,000,000 times, and if you install like 400 megabytes of dependencies because you build a container that is for your software. It's not your production container, but you need all the build dependencies in this container. This can be huge very, very soon. So what I do when I develop Docker container images, I look for the base image I'm going to use. Either it's NodeJS or Alpine or Ubuntu or Unit or whatever image you want to use, or your own base images. Then you start this image in a way, for example, Docker run -it for interactive TTY. So that means I can actually type something then. Then you can use a bind mount if you would like to test something with your data. And then you type the image. In this case, let's use NGINX as a base image for what's worse. And then at the end, bin bash. So now you see we are here. Good. And now when I type up update, I will update my repository catalog. Good. So let's give it a while I'm talking. So what happened is I have this now on one screen. And I have my text editor IDE on the other screen. And what I'm basically doing is I'm bind mounting or create a copy of my data in a zip archive or something, and then I'm bind mounting the data in interactive container. And what I'm actually doing next is like a live development of this Docker image. So I know what I want to do. Like, for example, if I need JQ to parse some JSON data, and I'm pretty sure JQ is not part of the default NGINX image. It's not. So I have to install it. So I do update, perfect, and then I'm doing this and install JQ. And there's another thing, this little -y. If I'm doing this live development process of a Docker image, make sure anytime you're typing something in your active shell that you do not need to type something extra than the command you're trying to execute. Otherwise, your build step will just fail, right? So if you just type apt install JQ, it will wait for this little OK click that you're fine to install the library and that it consumes, I don't know, like 5 megabyte or something of your disk space. And then the build step will fail. So make sure you type -y, so it will just run smoothly without asking for anything else. Good. So now it's JQ. I can use it, actually. Perfect. And I've installed it in the container. So what I do next is I can do some tests in my container, and then I jump in my IDE and type in my Docker file, run update and apt install -y JQ. So then I go back into my interactive container and do all the stuff I have to do. And each step I'm doing live in my container, I'm like copying over into my Docker image in this Docker file, basically. So this helps me because I can interactively do the development of my Docker image in this interactive terminal and can test things out and can try them. And it's like navigating in a normal shell. And as soon as I have a solution in my container image that works fine, I just copy what I have into the Docker file. And at the very end, I can just run Docker build. Sometimes it works on the first try. Sometimes I forgot to add some non-blocking things like this -y, for example. But most of the time, this is a lot more efficient than just doing the Docker file and build it all the time. All right? This is my pro tip for building and creating Docker files. Oh, yeah, that is exact because, for example, if you would like to jump in a container that runs from multiple terminals, then you can use exec to directly jump into this one. So you can start it up, let it sit somewhere, and if you do not start it with Docker run -it bin bash, then you have to do the exec thing to jump directly in the container. So it's the reason why I'm saying it is because the Docker exec command, for me, is one of the most important things. Because if sometimes something is not working as expected from outside the container, I would like to go in the container to see what the heck is going on. And that's when I use Docker exec. So it sounds always like a special thing, because we all know Docker run and Docker stop and whatever, but Docker exec to me is one of the most interesting things, just to see what's going on inside the container. Great, so this is what we can see here in the containers. Let me just see, yeah, we have 10 minutes for Docker desktop left. So that's Docker exec. And then it's like, yeah, you can just show my running containers, because if they are stopped, fine. Just running containers, also good. Images is something we already saw. That's all the images you have on your system. And another thing that is like a pro tip when it comes to images, the images mostly stored on Docker Hub. So you can download them by Docker pull image name. If it's not already present, then it will download it. If you type Docker run and the image is not present, you know this pulling from Docker Hub thing. Perfect. But can I see with show of hands, how many times have you at least typed this Docker run command 3 times because of this image name at the very end is like somehow wrong, and it was not able to find the image on Docker Hub? Like, I want to run GitLab, enter. Okay, wasn't fine. GitLab -ce, GitLab CE, and then it has special tags, no latest. So then there's a Docker CLI command that is Docker search. You can search from the CLI, the Docker Hub, and say Docker search, and then type an image name. Docker let's go out of this thing. Then we type docker search NGINX. And it will show you, okay, what are the NGINX containers? So, but one thing that I always miss when I do Docker search, it's not showing all the text. It's literally showing the image name. That's fine. But this is in some cases, for example, when I look for our unit container, we will use later, con type unit. It will show me that there is something that is called NGINX Unit, but it's not saying, okay, what are the tags I can use? So I can go to Docker Hub, or I can use Command K here and type unit. And then Docker Desktop will open this magic search, and I really like this because of a couple of reasons. First, it will show me here, this is the official image, perfect. And here it has this little tag dropdown. So I can see what are like the current tags and kind of select one. And then I can run it, I can pull it. I can see here the documentation about an image. And this is especially when we come to develop a container image, or if you want, for example, this little example we had, that you would like to split your images or your services into different things, and you would like to containerize your application with a compose file. The Docker Desktop search for images on Hub and all the documentation is something I use since I'm using Docker Desktop more often than going to Docker Hub on the website, right? So type the image name, Control K, or use the search bar here. Then you can click on the image. Here is the tag. Then choose one, and then you can see here the documentation. You can pull a given tag. You can run it. That's just easier than go to the Docker Hub itself.
Where were you in the desktop application when you issued?
Oh, there's a search bar here, right on top. You can click in the search bar, or you can use the Command K key, or I think on Windows it's Control K, to jump in the search bar. Right? So let's make an example. If we would like to use MariaDB as a database, we can search it, and you can click on it, and it will pull up the documentation here. Then you can copy you can search for 11.1. It will automatically change here the command. And if you can click Docker pull, but if you would like to issue this on a development machine that's not your local machine, just copy that here and dump it in the terminal, and it will work. So to me, this is a lot more efficient than just going to Docker Hub and do this like in a web browser. Because I don't have to leave my Docker Desktop for searching images and doing like, to find the images I would like to use for my Docker Compose file. Is Docker Compose clear to anybody what that is, for what it can be used, or is there anybody here that says Docker Compose is new? Never heard about it. Okay? So one sentence about Docker Compose then, and then we move on to the next thing. Docker Compose is basically a description of a stack of different containers and how they interact with each other. So, for example, if you run a container using Docker run, you have always the problem, how do you document, basically, for another person on another machine, what ports you want to expose? What environment variables do you want to set? What bind mounts do you need? What kind of maybe extra entry point at the end? This bin bash at the end is the entry point. If you would like to document this, even for a single container, I always advise using Docker Desktop, and you will use Docker Desktop here, of course. We will use this, and I can show you how that works, because it will describe the whole stack. It will describe how the container image is, what are the environment variables, what are the ports you would like to expose. So and if you do this for multiple containers, you can use Compose to start up multiple containers. Good example, and that's what we do here today, so you're definitely in the right course. We will use a database together with PHP, for example, right? So you would like to spin up the database, and then you would like to administrate your database with PHP-admin. So what you can do, you can spin up MariaDB, you can spin up a database, and you can spin up PHP-admin to administrate the database just by simply use a Docker Compose file. And this is something we will do. Great. So that's what I'm saying. To get image names and stuff is important. So Docker Hub is good, and Docker Desktop gives you a very neat interface to search images on Docker Hub.
I have a quick question.
Yes?
If I start a bunch of containers with Compose, and then I'm in desktop,
Mm-hmm.
is there a way from Docker Desktop to see the Compose that launched the Kubernetes?
Yes. Yes, there is one. If you go here in containers, for example, let me do this real quick. Good question. I think, let me just, it is actually very hard to stay and type. Can't tell you. This is something for later, but it doesn't really matter. Let's do this right now. I hope it's okay if we do some jumps here. So let's use nvim. I think that will do a little print. Yes. So this is a Docker Compose file. That's how it looks like. So we define services with names. That's web. That's NGINX. That's a PHP FPM. We need that later. But let's spin up this thing just by run docker up docker compose up. So right now it will pull it down. It will download the images from Docker Hub, and let's see. So now here in containers, it's still downloading. And this is another nice thing, because if you use the Docker CLI to, like you can use Docker Compose to print what are the containers. This is always advised if you are using compose files and the compose in your process. You can type docker ps to show all the containers. The only indication you have with docker ps that these containers are like together in one compose file is the name at the end. If you change the name, it is really hard to see in the docker ps output what containers are in this compose file. There is another, another argument in Docker Compose, ls, to print all the compose projects and the containers that are running inside of this project. Because if you have like 2, 3, 4 different projects currently running on your machine, and you just type docker ps, it is really huge output, and it will become a little bit difficult to understand what container belongs to what compose project. So it's still downloading. Yeah, but we'll be finished in a minute. And good point, we need this later anyway, so it's a good thing that we're downloading it right now. And here, in the container overview, as soon as this is up and running, we will see there is this stack icon, and then we will see this is the compose project, and then we see all the containers that are inside of this compose thing. So it's, again, another nice overview of what's going on my machine currently. All right, so I let that download. And while this is downloading, we can do then the overview of the project. Okay. So that was part of my pro tips for using Docker Desktop. In the settings pane, there is basically not really much special to say. Kubernetes is interesting, but I know there are plenty of. Go ahead. Yes, you can. So yeah, in the settings there is a Kubernetes thing, but I know that we have plenty of sessions here about Kubernetes itself, so we'll not cover this. But this option is really handy because it starts a single node cluster, Kubernetes cluster, on your machine when starting Docker Desktop. So that means if you're using Kubernetes in your day-to-day business as a developer, sometimes you would like to check out if your Helm chart. Helm is a packaging program or packaging project for Kubernetes deployments. If you would like to understand how your Helm chart is working or how your container works or your manifest you're creating for Kubernetes, you can use something different, of course, but for quick and dirty testing, this Kubernetes thing is really great. I used that a couple of times as well. That's great. I mean, I'm doing Kubernetes from time to time, building Helm charts and stuff. And for this testing, this is absolutely great because you don't mess up with this whole kube control thing and minikube and another VM that's simply click enable Kubernetes. Then you have all the Kubernetes tools you need, and it just works. It's super simple. And I disable it most of the time when I'm not needed to save resources, especially when I'm traveling on the plane. The compose, I will not forget about the composting. But there is since the latest 2 versions of Docker Desktop, they have improved the consumption of CPU and RAM dramatically. So it's dropped by 50%. Not just because they say it online, but because I have used Docker Desktop on flights a lot. And prior, the latest 2 versions, it was always like reducing your battery life by, I don't know, 60% or something, right? And with the newer version, they have some SEM memory saving mode. So that means anytime the Docker Desktop is detecting some idling stuff, can turn it off. So it really saves you memory. And new since the latest version, I really like this. If you want to stop or pause or do anything with your engine, I don't know if you see that. It's right here on the very bottom left in your Docker Desktop pane. You have now quick buttons for the Docker engine. You can stop them, you can pause them, you can restart them. Before that, you always had to go here in the settings or right mouse click to the Docker thing and then go here and say pause, restart, quit. Here. And that's now here. It's like one right click less. And you don't need this actually very often. Sometimes you would like to pause it. And the composting. Now you can see this. It's downloaded. We see it's NGINX and Docker and PHP FPM in, what color is that here? Like I don't know, yellow, brown, that's blue. So if we go here, we see this. We have the NGINX PHP FPM project, and it says now PHP FPM and NGINX. So you can see this stack, and it shows you that we have 2 containers running in this stack. And your question about running compose files from Docker Desktop is something you can use this development environment. There is dev environment. It's currently in a beta mode, but you can create this. And this is basically creating a Docker compose for you. So you can give it a name. You can use an existing Git repository or a local directory. Select one. Then it will basically prepare all the images for you, and then you can use the dev environment to spin up this Docker Compose. The dev environment, to me, is kind of a UI for creating Docker Compose stacks. Actually, haven't really used it a lot. Reason for that is maybe I should try that, because I have like lots of Docker Compose files already ready. So you have GitHub repositories as templates. So to me, it's not really interesting to basically create them from scratch again. But I think, and this is something we can try if we have some time, I think, if we can load a Docker Compose file here in Docker Desktop and see if that works. Yeah, I think that should work then. Let me see. When we do dev environment, create new, and then I love screwing things up. Add presentations. DockerCon 23. Local directory, select, like where is Docker? Holy cow. Docker, DockerCon. Is here? Yeah, there's the compose one. Okay, open, continue. Well, let's see. There's a compose file in it. That's what we just started like 10 minutes ago. Let's see what this thing is doing. Yep. All right, the question was, what is the difference between a Docker file and a Docker Compose file? Sorry, a Docker file is defining a single container image. It's like you're building construction plan for a Docker image. A Docker Compose file is more of a construction plan or instructions for your whole service. For example, if you need a web application that has a database, PHP my admin, an NGINX web server, and this is something what we will do today. A NodeJS backend, another NGINX container for something different. Then you have like 5 or 6 different Docker containers. And then this is a compose file. This is what we have in a compose file. So cod compose YAML, or use nvim. See, this is not this YAML syntax is not what we have in a Docker file, right? So what you see here is we define services. Web is a service. And this can here, you see, this is build, and build tells Docker Compose, go in this NGINX directory, use this Docker file. In this case, you don't have to define Docker file as a separate line, because the Docker file is the default. If we say go in the NGINX thing and build the container, it will automatically look for Docker file. Reason why I'm defining this here is because then I can tell you if you have a Docker file for production that is dockerfile.dev, dockerfile.something different for whatever reason, you can use the Docker file tag here or the configuration to define, okay, what Docker file you want to build. See, this is the reference between what is a Docker file and what is Docker Compose. Docker Compose defines your services and the way you deploy your services, even on production environments, to be honest. It's not a development thing alone. You can fairly use Docker Compose on production environments as well. Yes? Sorry? So this is, the question is if this is like a service file for Kubernetes. That's not aligned to Kubernetes at all. A service definition, a service YAML for Kubernetes has the same syntax because it's YAML as well, but it has a different, it looks different. It looks different. So this is not a service file for Kubernetes. This is a definition for Docker Compose. A service definition for Kubernetes looks a little bit different. No, you cannot use a Docker Compose file to just deploy a Kubernetes service. Yeah, you can. I mean, if you have a Docker Compose file, you can create service files out of a Compose file, but not like automatically. You have to combine, like write them, but it works. What link? What do you mean? Oh, links. Oh, okay, good point. Links. Okay. The question was, what does this link mean here? A link here means that depends on, and link means that this NGINX image here depends on the PHP FPM one. That means I have to start up the PHP FPM first, and then I can start NGINX. And links is like that we connect them on the network level, so they can work with each other and can connect to each other. And this could maybe something for the Active Directory thing, but this is. Yeah, I guess you have the Active Directory outside of a container, right? So, so we will have a look on this problem in the break. Yeah.
How is the links different from specifying a network?
Network tells the Kubernetes. Network tells the Docker Compose what network to use, and with link, we can, for example, exec or use the name of the FPM inside of the container to simply navigate to that. And that's what we see in the, let me show you this. Here, we see we have the name of this one, of this FPM thing. There is a container named PHP FPM. See this? This one? And now when we look in the documentation, in the NGINX config, see? Then we say it's PHP FPM port 9000. We don't have to expose port 9000 to our host machine because it's not needed, because Docker creates a network, like a NAT network for this Compose project. And what we do is Docker puts some hosts magic in each container that then resolve to an IP address. At the end, it's behind an FPM is like the PHP FPM name is a link to a given IP address, of course, because we're doing TCP, of course. So in layer 4 and 3 on the network cannot really work with names, right? So we need an IP address to do an actual binding to the FPM port, which is 9000. But Docker knows how to do it. Docker knows what IP address is behind PHP FPM, and this is something we can find out using Docker Desktop as well. Absolutely amazing, it's saying error. Okay. Oh, it's already used by another container. Yeah, I think it will work as soon as we delete this. I'm pretty sure we can use Docker Compose files in the dev environment as a getting started point. I will test this in the break. So.
What did you say uses port 9000 by default?
That's the FPM settings basically inside of the. That's default. See, we're just saying PHP. Oh, that's old. PHP 8116 FPM, and per default, it's using port 9000 as the entry point for the FPM. That's something we can look up in the documentation using, for example, Docker Desktop, check PHP 8116 FPM, and then we can see this. And the error we just got in the Docker development environment was saying, hey, you're trying to create a container that is named PHP FPM, and you cannot do it because there's already a name. And the names, as you can now imagine, because of this IP address thing, they are unique. That's why Docker is always creating these funny names. If you don't define a name and you type Docker run something, you will have this funny name, this funny container name. Have you ever seen this? Yeah? Stupified query, interesting. Things like that, that's pretty amazing. So that's why. And now the Docker PS thing, or the Docker Compose thing is telling me that the PHP FPM already exists, so it's here. So we can delete it, delete forever. Don't need it anymore. Go away. Start. Oh, it works. Yep. Let me see. PHP FPM. Exec. Yep. OK, so it works. So what we just did here was, there was the question, can we just host a Docker Compose file in Docker Desktop? What I've done is I've used the dev environment, and then I created a new one. And then I pointed this next step to a local repository where to this PHP FPM thing where the Docker Compose file was already in it. And then I just said launch. Pulled down all the images, and now it's created this thing. I have no idea what this is. But this is something I will find out in the break. But in general, it works. So that means we can use the dev environment to basically host our Docker Compose files in Docker Desktop. And then we can see here again, this is the stack here, DockerCon 23. It's saying running 3 out of 3. And then if we click on it, we see we have the PHP FPM and we have the NGINX one. So that's why I'm saying this Docker Desktop gives you a nice overview about what's going on in your Compose projects. And Compose, to me, is one of the most important things when it comes to development and web development with Docker, because it will just define the stack you need to launch an application. And this is something that's very interesting for you, actually, when it comes to break your applications into smaller pieces and you would like to refactor huge applications into smaller pieces. Docker Compose is very important because it describes what's basically needed to launch and spin up the application for development, right? So we will see this during the course. All right. So then Docker extensions, yeah, I said pretty neat, pretty interesting thing. I have created this Docker Desktop extension for NGINX a while ago, and extension is a great thing to enhance the productivity from Docker Desktop even further. There is a catalog here. You can browse and you can install, like, there are many, many, many extensions, and they will be more every day. If you have an idea, create a Docker Desktop extension, very simple, easy process. For example, here we have the NGINX extension. What's the normal way of managing NGINX on your dev machine? When you're doing Docker Compose, you're using Docker exec, or you bind it the config in your NGINX container, then you change the configuration, so you have to reload NGINX, you go Docker exec, NGINX is reload, annoying, inefficient. With the extension, we can see, okay, this is the extension, that's the container ID, it exposes port 80, it is this file for find here that we can use, we can change it, we can do some changes to the file, and then at the end we say publish, and it will upload the configuration and automatically restart NGINX in the background. So it's just efficiency, yes?
You wrote this extension?
I wrote this, yes.
I just started using it yesterday.
Perfect. Oh, literally cool. That's good. That's great. So tell me if you have any problems with it. Then.
It's really nice because the desktop popped up and said you should be using this, otherwise I wouldn't have known about it.
Okay.
How does that alert happen for an extension?
Yeah, that's because we were, like, Docker were thinking about recommendations about extensions for given processes or given, like, specific user groups. If you're a web developer, it is very, very likely that you will need some proxy server somewhere in your Docker Desktop environment just because to deal with stupid course headers. And we will see this today because this is the most common pain point when you do even web development locally. You have a front end that is localhost 3000. You have an API that is localhost port 8080. You try to combine them, and the first thing you see in your browser is, hey, there's no course header. It is localhost. I don't care. We need course. It's localhost. I don't care. So we need course. So, and to do this, Docker Desktop and the extension is really helpful. And because it has, how many downloads does it? It's like, Jesus, let me see. Oh, 21,000. That's good. So, so that's why. Docker sees, hey, 21,000 downloads. So looks like people need it. People find it useful. So that's why you see this recommendation. And we will use the Docker Desktop extension from NGINX through this course. So good. So this is extensions. Another reason why I really love Docker Desktop, because with the extensions, you can do, like, resource monitoring and see why your machine is freaking out because you're running Jenkins and GitLab and another Java process, and that's eating up all your memory, for example. So that's what you can easily see here in this resource consumption thing. Let me check the timeline. Holy cow. We have a tea break, actually, right now. That's bad. OK. We do this, and then I will jump. Oh, well, I will shift gears a little bit then. We will do the Docker Scout and vulnerability scanning. That's a word. Then when we introduce the vulnerability scan in the process later. It's part of Docker Desktop. It's part of the CLI. But we will do that later, then after the break. So that means after the break, I have to give you a very, very quick introduction to the project we're going to build because I have talked too much about Docker Desktop and how to get started. But I hope that is interesting for you because that's the most important thing because you can waste a ton of time using Compose and the whole thing just not efficiently enough. Oh, cool. Yes? Yep. What images do we need? That's an excellent idea. You can pull down NodeJS. NodeJS is something we need. Version doesn't really matter. 20 should be fine. Node.js. NGINX, of course. The PHP FPM. There is a Git repository for the PHP FPM and the. Let me show you this the Git repository. Because then you can pull this NGINX FPM example, because I have something that is a lot simpler than FPM. That's why. Yeah, it's on my GitHub repository. It's this. And this will pull down at least it's an older FPM image, but it doesn't really matter. Can you see that okay? No, because it's on the very bottom of the page. It's this one. It's GitHub, my interesting username, and then nginx-php fpm. If you pull this image, like this repository, and then if you do Docker Compose up, for example, it will automatically pull down at least the nginx and at least the FPM image. So we have something we can play around with. If you really want to, and that's something I'm doing here, actually. Would be good to have like MariaDB and PHP-MyAdmin, so I can show you how to set up a database and using PHP-MyAdmin to do this. So that would be MariaDB and PHP-MyAdmin. So that is MariaDB. And PHP-MyAdmin. So this is something where I love the Docker ecosystem in general, and then we do the break, promise. I mean, you don't even care about how to set up PHP-MyAdmin. You just pull down the container. And to me, it doesn't really matter, even if I work for NGINX, if there's an Apache web server in it or not. I don't care. I need PHP FPM. I don't care about the web server it's using, right? So to me, it's just pulling down, use it, and that's it. So, but if not, I will share everything we are doing here is something I will push to a GitHub repository. It's not there yet, because if we have some like other things you would like to do, and then I can put everything in and just push it after the thing, and then you will get the link. So if you want to do this at home, no worries. And then we do the break. I'm working on a course guide. Just started with it yesterday. Where is it? Here. So we'll work on this, and this will have all the things we're basically doing in it as well, right? It's just not done yet. Just started on yesterday. But if you think that's helpful, I will just put everything we do in a PDF and just drop it after the conference. Then you will see it in the GitHub repository, and then you can just pull it down, and it has all the stuff in it. OK? Perfect. All right, now we do the break. Are 10 minutes fine for everybody? 10-minute break is good? All right. Oh, yeah, the Wi-Fi is not super fast. Sorry? Fine. You can use the Bitnami one, or you can use the official one. Like, official is then, the official PHP FPM is a tag of PHP. So if you type, that's sometimes a little bit weird. If you search for PHP-FPM, you will not find the PHP one because it's a tag. You have to search for PHP, and then you can find the FPM as a specific tag in this PHP image. But as I said, if we have trouble downloading it, let me make some notes on the side. Next time we do this workshop, I will let you know before what images we are going to use. So high-level project architecture of a common web development project. We have some kind of front-end. It can be integrated in the backend language like PHP or Ruby, Rails, something. But in many cases, like today, it is something like React or Vue or Angular or kind of a front-end framework that you're using. So you have it's decoupled from your APIs. This is where the cross-problematic comes into play then. Right? So, and we can start this, and we will do this. We can do this npm run dev thing. We can do npm build to build all this kind of things. npm is the Node package manager. We will use this. So and then we have, we have the backend. And the backend can be in like all the different languages you can think of. And it doesn't really matter what language you're using. It can be Ruby or PHP or TypeScript, which is like JavaScript. It's not JavaScript, but it's well fitted into this JavaScript ecosystem. It can be a Rust API, like or Kotlin, Java API, whatever. It doesn't really matter.
In a sentence, do you think TypeScript is worth the time?
I love it. I love TypeScript. All my projects are using TypeScript. When I do anything, even on the front end side, I'm always using TypeScript. That's like even if it hurts sometimes because of all the interfaces and types. I mean, it's not like JavaScript. You cannot say, hey, I have a class or like JavaScript doesn't matter if it's an integer or a string or an array or an object. It doesn't really matter. If you have a property in a class that's called something, you can put really literally something in it. JavaScript don't care about it. It's fine. And in TypeScript, you have to basically describe, hey, I have an interface, I have a class, an interface, and I have like a couple of fields, and if this field is an integer or a number, and you try to put an object in it, it will scream and cry and say, hey, this does not work. This will not work. Define it right. So yeah, but I love this TypeScript feeling. And we will see I have some stuff not really prepared, but I have some thoughts about how I'm always creating TypeScript projects for ReactJS, for example, and how the directory structure look like and how to interact with different services. And if you're all interested in seeing this, I'm more than happy to share that. So all prepared, we can see that. Good. The backend can be TypeScript or PHP. In this case, we're doing a Node.js backend and a PHP backend. And then this is what you have on your laptop most of the time. You have something that listens on port 3000, and then you have something that listens on port 8080, and something that listens on port 8090. But just the backend and just PHP and just TypeScript isn't good enough, right? We have a bunch of other stuff. We have a database somewhere. It can be MariaDB, or it can be Postgres. Sometimes you have one service that uses Postgres, and you have another one that uses MariaDB. Awesome, great, excellent. So we have Postgres and MariaDB on your system. And then we need something to administrate the databases, even on our development machine. phpMyAdmin, pgadmin. Or you use some tools like the MySQL Workbench or something. There are some slight differences, like what you want to use to administrate your database when it comes to setting up all these things here. And Minio is, for example, a nice little object store that is compatible with AWS S3, for example. So if you have an API, or if you have services that normally would dump data to AWS S3, and you would like to do this on your system without dealing with AWS S3 while development, then you can use Minio. That's basically what I'm doing all the time. So
What admin tool would you use for MongoDB?
for MongoDB, there is something that is called, that's not advertising, by the way. That's just what I'm using. There is something like NoSQL editor, NoSQL editor. It's like a little green leaf. I use that. It's no advertising. Use whatever you want, but that's what I'm using. I love it. So it's called NoSQL editor. Yeah, actually, I found a CVE by them, so I got a premium license for free. That was still using that one. So look for CVEs, and then you'll get a lifetime license for free. All right, good. yeah, MongoDB is another good example. I'm using MongoDB in some of my Java projects. And as you can see, the reason why I put this on the slide, and this is one of the view slides I have, like not many more, is because the stack can be very complex very soon, even for small projects. Because what is a small project? Is it 2 or 3 different services? And you will likely have 2 or 3 different services today. Mongo, MariaDB, Postgres, Minio, maybe Redis for caching something. So that means you have at least 5 things, call it things or containers or whatever, that's needed before you even start writing a single line of code, right? So this is why we are here, because I would like to teach you or show you how I manage this stuff efficiently. All right. So then this is my favorite thing, always. Love it. You do development locally and you use in your Node.js or in your React applications, you use an API that is on localhost port 8080, and the first thing the browser is doing is saying, hey, this is not working because there's no course header. I don't care, it's localhost. I don't care. So
Sometimes even a 500 error is like given as a call or why is that? I have faced it multiple times, like it's a 500 error.
right.
Showing up as a cause.
Good. OK, so what is course? Is it fine if we talk 2 minutes about this everybody's darling? OK, good. What is course? Cross-origin resource sharing is the long version of what course does, what does it mean. And it's like the browser checks if an API or a resource that is not your origin. What is origin? Origin, in this case, if our front end runs on localhost port 3000, this is our origin, like our home. This is where we live currently with our application. Good. If we try to consume data from another origin, localhost port 8080 is another origin. That's important. It's another origin because the port is different. It's another origin. So the browser requests a resource that is hosted on localhost port 8000 or 8080. And what the browser will do in this case, because you do the call from JavaScript or TypeScript from your React project, you're not using the browser to navigate in a new tab to localhost port 8080. And this is a common mistake. If you do a browser tab, a new browser tab, and do localhost port 8080, it will work. It will show you the JSON output. Why not? I mean, you're navigating to this endpoint. That's totally fair. But if you do the same thing from inside of your React app, and we will do this here, it will tell you, I cannot get the data from localhost port 8080 because this cross-domain allow origin headers thing is missing. And that is because it's the browser tries to prevent resources, in this case our front end, to get information they're not authorized to get. And this is the thing. And I remember I was working almost 10 years for a German car manufacturer. And remember I explained that in a meeting because they added course headers everywhere. Not kidding. Everywhere because they literally did not understand how that works. They added everywhere a course header. I was like, look, this will not work. Because the point or the place where you have to add the course headers is on the backend API. You don't have to set a course header for your front end. The front end literally don't care about a course header. That's not the right place to set. Because the front end calls your backend API, and because of this cross-origin sharing, the browser says, hey, do you even have permission to get this resource from this other origin? So let me tell or ask this origin, localhost port 8080, if you have permission to get those data. So it will ask your API, hey, do you want that this front end is displaying your data? And if the API says, oh, fine, do it, send it, then you will see the data. The front end doesn't care, right? So this is where to put the course headers. It's on the API side. It's on your backend side. It's not on the front end. So don't put them everywhere, right? But we can do some course juggling later, like what does star mean? What is a, and I have a nice trick. I think it's one of my production servers. So maybe I have to drop screen sharing for a little minute, and then because I have a nice little trick how to do this, like course headers with different host names, because you cannot put in this cross allow origin header, you can put star in it, or you can put a domain name in it, but you cannot put a list of domain names in it. But I have an NGINX configuration that gets the domain name dynamically and then puts always the right domain name in it. So, I think I can share this one with you. Okay, so we have the course headers even locally. That's where the proxy comes into play, even on your local machine, because you don't want to have this course errors. Then you add the course headers, then you remove this, you wire things a little bit different. So then you have this. You have NPM that your local front end is talking to your proxy server, which is hopefully NGINX on your local machine, and then this will proxy to the different Docker containers on port 80, 80, 80, 90, and add some course headers. And you don't have to you can even have NGINX listen on port 8091, 8092, and then proxy to your containers as well. And this is again where the Docker desktop extension comes in handy, because let me show you this real quick.
Is this proxy the same as a reverse?
Yes, that's literally a reverse proxy. It accepts traffic on a given port, knows what to do with it, and just sends it to the upstream. That's basically what it does. So the good thing is with the Docker desktop extension, let me see. Yeah, I have this. Oh. Where do I have it? I think it's here. Because in the Docker desktop extension, I'll show you that in a minute. It knows what other containers with what ports are in the same network, and then you can select them when you're creating a new configuration, basically.
So you only have to add the course headers to the proxy, not to all the backend servers or services?
Just the proxy. Proxy is dealing with the course then. And we can do that in a minute. So this is Docker Compose Watch. That's for later. Good. So now the components we are trying to set up. This is something we already saw, basically. And now I will show you something. Yes. All right, so this is a real project. I don't like to to create, no, that's not a real project, that's just a black screen. That's interesting. Let me try. Okay, I'm presenting mode in PowerPoint again. Let's see. Yes. Okay. Now I hit and exit. Let's see. Yes. Yes. Okay, perfect. It was just too fast. Okay, so this is a real project I'm working on. Like something that you can use to book courses for the fire departments in the city where I live. You can book courses, and they did that manually, and they asked me a couple of months ago, hey, can you create a website for this? Yes, of course I can, and this is the project. So, real project. So, it's not a demo thing, it's a real project. So, we use this as a reference, because I don't see a reason why to create a thing, or I have created the same directory structure. Now we can move parts into this directory structure, and then we can push it on GitHub so you can download it, because this is a private project. It's not even public, the source code, so it's like, closed source, so I will copy what we need. So, but you see this directory structure. We have a backend directory, we have a DB, we have frontend, we have proxy. I like this directory structure because of a given reason. And this is where Docker Compose comes into play. Let's imagine you start a new project and you own the whole project. Like you do the front end, In this case, I own the whole project. I do the front end and the back end and the database and the proxy and everything. So, but then I can push it to Git. Okay, so we have a Git repository that has all the different things in it, like the back end or the front end. Good. With this structure, we can easily say today or tomorrow or next year, somebody is taking care of the backend. I'm not doing it anymore because somebody else is writing the backend code for me, which is fine. What I can do is I can get this backend code and just move it into a completely different GitHub repository and use something on Git that's called submodules and just put it back in my GitHub repository. So what will happen is that I have one GitHub repository with all the front-end code, and this has a reference to this GitHub repository that's the backend. And it's a submodule. I'm not even owning this thing anymore, but I can try Docker pull then or clone and include all the submodules so that it will get the latest version of the backend on my system without me even taking care of it. And this is where Docker Compose comes into very, very handy. And this is what I would like to show you here. Good. So again, we have the services, we have the proxy, we have the backend. What you see here is in the proxy section, we have this context that's saying, hey, /context is proxy. Proxy is the directory name where, call this however you want, beaker or whatever, something meaningful, please, that others that are new to this project can understand, hey, what's going on. And this is the reason why I use Docker Compose file for most of my projects, because I would like to let others know how this project works. And it doesn't matter how complex it will be at the end. If your Docker Compose file is structured well enough, and you have these directories set up at the beginning in a meaningful way, if you have multiple backends, I love to do backends, plural, and in backends, I do Java backend, PHP backend, Node backend, that people understand, hey, this is my backend. Okay, fine. This is my front end. In front end, I do React. Reason why I'm doing this is because if you're new to a project and you don't know what React is for whatever reason, it's unlikely, but maybe you don't know what React is. But you know what a front end is most of the time, right? So you go to front end and you see in this front end directory, you see something that's called React. You can, in this second, you understand this React thing, whatever that is the front end. Perfect. So you can Google React front end. You can link things logically together and understand what that is. If you are in backend, and in backend you have a service that is NodeJS API, if you just imagine, you have a directory and that is front-end code somewhere, and then in the same directory you have your backend API, and it's just a folder that's called Node. What does it say? Nothing. You have a very hard job finding out what is Node. What is this directory Node doing? What is this? And I saw that like a million times, that just people dumping everything in a single directory, and then having trouble to linking things logically together, and it's a mess. It's literally a mess. You're mixing up things, and then you rename. What I saw, like, you have source src for the backend, and then they had a source underscore frontend folder for the frontend. I mean, it becomes very messy at some point.
Would you classify microservices as things in that back end?
Mm-hmm. Yeah, if you will, you can do that. So, and this is what I have in the example we're doing here as well. So the directory structure, to me, matters the most. If we get started with development, and I have a Git template, I should share that as well, where I have this kind of directory structure created at the beginning. It has a proxy folder always. It has a database folder always. It has a backend folder and a front-end folder or directory. And one Docker Compose file. And what does this Docker Compose file do, actually? What we see here is, here, for example, we have this PHP my admin. We have a DB. We have a couple of volumes and secrets. Perfect. And it's just for development. OK. And what matters, as said, most to me is first the directory structure. Make it meaningful. Say proxy, front end, backends. Then put a lot of stuff into backends. That helps people to navigate in your project and instantly understand what does it do. Second is make the compose file or the whole project using Docker Compose self-contained. What does it mean? Show of hands. Who pulled a project from the internal or external Git repository, tried the build sh script or Docker build or Docker Compose, and it errored the first time because of a missing reference? Database was empty. It was not able to build because the dependency was not there, or it built, it started up, but the front end or the back end errored because there were no data in the database, something like this, right? This is not good because you're doing it, you're working on this by yourself for a couple of months, and you put everything you have, for example, a database already on your system. You have a Redis on your system, a MongoDB, it doesn't really matter. And during this whole cycle of development, you put a lot of data in it. So for you, it is totally fair that there is a user database table and there is a couple of data in it. It works. It just works. OK. Or you put a JSON file somewhere on your computer that is needed by this project just because you know that it must be there. Perfect. Good. So now another engineer tries to work on this project, and the simple thing to onboard somebody is by working with the code. Reading the code is one thing, but as soon as it's very complex, and it will be very complex very fast, is you pull down the data from Git or from somewhere or from a tarball zip archive. It doesn't really matter. You have it on your system, and then you can look at the code, but it would be very nice if you can just run it, click through it, and watch the front end, look at the front end, see how it interacts with the back end, use Postman to check the APIs and all this kind of stuff, right? So that's what I'm saying. Make it self-contained. Push something to your Git that just works by typing docker compose up -- build. It just works. It must work. This is a must-have. If you're responsible for this, like I'm calling that like the level 0, if you're responsible for this directory structure, like for the overall thing, make sure that this Docker Compose thing has anything in it you need to spin up this project, to run it. Everything, a database, my PHP, my admin. If you need Postgres, fine, put Postgres in. If you need MongoDB, put MongoDB in. If you need some example data, make sure that they are part of your thing here. So for example, I have in the DB folder, there's something that's called dumps. All right, excellent. And in dumps, I have like a SQL file that has at least the structure and the minimum set of data. Default user, admin, whatever. It's just for development. Don't put it with production data, of course. You can dump production database and delete everything and just have like some sample data in it. Perfect. One thing. Another option is to use some tools to generate database schemas and data while it's building. Java has, like, Hibernate is a common thing where you don't have to do this database stuff by yourself because the framework is actually talking with the database and creating schemas and inserting data. That's what I'm saying. This is not like black or white. I'm not saying you always have to put an SQL dump in your Docker Compose file to set up your database. No. If you use something like Hibernate in Kotlin or Java or something like Ruby on Rails, has similar ideas that you describe in a file what your data, or how your database should look like, then it's creating the database while it's starting up. So it detects, hey, there are unmanaged, unstaged changes to the database? Yes, OK, let's do it then. OK. But make sure that this happens, that this will be executed on startup. And this is my #1 pro tip for all of you. Make sure that your Docker Compose setup and your Docker Compose thing works out of the box. Let me actually see if this is working. So I'm not sure if I did some changes to this. Right, while it's pulling, this would be interesting. If this fails now because of a missing dependency, then that would be interesting. It's, yeah,
Do as I say.
yeah, sometimes. All right, sometimes it's like this. Okay, so while this is building, let's leave it for a minute. By the way, is black better or white better? Just go ahead. Black is better? Because yeah, I was trying to make it like for you better to see. If you're saying black is better, we can switch to black. Black. Session. Where's that? Where's my profile? Default. All right, so let's create some stuff. All right, so we have a README. So how to get started? Just create a directory, something, new project. Then a README. What is in a README actually? Nothing. Cool. Project structure built locally. Okay. And then we create some directories, backends or backend, database, front-end, proxy. Oh, sorry. So what files? Yeah. Yeah. Mm-hmm. All right, good question. No, just repeating the question. The question was if you have some user-specific data, like a GitLab token or GitHub token, access token, or .env file, like environment files you don't want to push to a Git. So yeah, if you have local, like localhost stuff, then I think an env file is possible, but this will not solve your problem because the GitHub token, if you have things that cannot be part of your compose thing, right, project, whatever, wrap it in, I think I have a build.sh file or call it star.sh or hello.sh, something that works. If you have like or a readme, something, and make sure it's described well enough. It's like, if you can't put everything you need in a Docker Compose file, then write it in the README. The very first thing, say, hey, thanks for working on this internal project. You have to do step 1, 2, 3 as a prerequisite. Otherwise, the Docker Compose will not work. So, for example, the LDAP thing. If you need some special credentials somewhere on your machine, otherwise it will not work, then you have to write it somewhere. And if that can be scripted in some sort, cool. Let's do it. Another neat thing I'm doing from time to time, depending on the project, I have sometimes an helper container image, like a setup container image, that is doing some of these initial setup tasks, if there are any, where you have to interactively like type in data, for example. You can use a container image that is commented out, for example, in the Docker Compose file, and then put paragraph in the README saying, hey, if you're starting up this for the first time, you have to pull up some credentials from the Active Directory, for example, or register this application at the IDP to get the handshake working. Anytime you interact with a huge third-party thing, identity providers, Active Directory, like databases or something, yeah, that's something then you can wrap in a shell script. Bash for Windows, another bash for macOS, it doesn't really matter. But just to make sure you should automate as much as you can. Not for the reason because it's then automated, because anything that's written in a script is at the same time documented for others. If you write it down in a script, say, hey, we do this to get the credentials, then it's documented. It's written down somewhere. It's not in a Word doc somewhere or in a Confluence. It sits with the code. So if you check out the code, it says what you have to do. So sometimes you're right, it's not possible to put anything in the compose. You should try to do it as often as you can. If it's not possible, describe it well enough. And make it easy to find those those information. Cool. Saying it's not completed. Okay. Installer is corrupted. All right, that's nice. Okay, black is better. So then let's use black. Okay, so we have the database, we have the front end, we have the proxy. All right, so I think in backends, I already have NodeJS and PHP and another one with PHP unit. And I think they're empty. Yes, they are empty. So we can write actually some code. Okay, so we can start with front end. Let me actually check something real quick. Yes. To set up backend and front end project directory into Docker Compose. Yeah, Docker Compose is something we already did. Okay, here is my app. I think I tested this yesterday just to make sure it works. Yes. So let's start with the front end then. Setting up a front end is like, yeah, it's basically depends on the framework you're using. In our case, we are using React as the front end. And to set up a project with React, there are npx and npm tools to do that. So, and in this case, we can use something like npx create React app. I think that's a very common thing. And then you just define the name React app my app 2. So in here, and this is something I would like to show you as well, because I see a lot of tutorials how to use or how to bring TypeScript to a React project. And then they start by creating a TypeScript project without React, and then they adding all the TypeScript stuff afterwards, which is, I don't know. I don't know why somebody would do that, because there is a template exactly for this reason that you can simply start with TypeScript. Why should I start without and add afterwards? Doesn't make any sense. So if you would like to create a React app and start with TypeScript, quit this, then there is a template. So reason why I'm jumping on this template thing so much is because I didn't really understand what templates are since for a long time, just used it. And then I was curious at one night and said, what is a template actually? What can I do with a template? And as I said, this is what I show you. I have a lot of code I usually have in my React applications because all of my front ends are interacting with some sort of API. So I have built some wrappers around. I'm not using Axios, for example. That's a third-party thing to do like API calls and network calls and stuff. I just build them by myself. I don't like third-party dependencies much. I use them from time to time, of course, like Express for backends. We do this here as well. But I just love to build something by myself because then I know it's working. And then I know it does not come with a ton of stuff that I'm not actually need. Another thing, when you work with Node and front-end and TypeScript and JavaScript, stop doing npming everything. This npm install stuff is great, but to me, it's like it get a little bit out of band. I see projects where they do npm install a third-party dependency to compare two strings or to get parts of a string. Hey, that's vanilla JavaScript. That's in JavaScript since the early 2000s, right? You don't have to do that. Stop npm install string compare. Why should you do this? Use vanilla JavaScript for that, right? So, okay, that was an emotional thing. So don't do this, yeah.
Just a quick difference between like npm, npx, and yarn, like how are they different? Like,
Right. So the question was, what is the difference between npm and npx and yarn? Yarn is literally a different binary. It's a complete separate project. It's not related to the npm thing. And npm is like the package manager for Node, and npx is another binary that comes with this like it has access to this templates and to this extra scripts. And in this case, we have to use npx because we need this create React app thing to bootstrapping our React application. And then we say at the end, template, TypeScript. So hit enter. It will think for a minute. OK. So now it says, OK, we're installing the package. We're installing React and React DOM and React scripts. And it will pull down some stuff. And I prepared that already. So just in case this is too slow, we can use it from the prepared thing. But I would like to show you how that works. Good. So and what is this template? A template is basically something we can use in this React. The template is something that comes from create React app. It's not an NPX thing in general. It is a feature for create React app. So reason why I'm saying it, I have custom templates. Because I thought, like, what I normally do is I say, OK, I have a new project. Cool. NPX create React app, my app template, TypeScript, enter. Fine. Next thing I'm doing, I open a GitHub repository, push everything in. Good. Then I open another terminal and copy all the common things I normally use, like my error handling fetch, my login handling fetch, all these things I built by myself because I don't want to put them in happy hacking. Good. I don't want to put them in an NPM package. I could do this, yes, but I don't see a reason why. I copied that all over to the other projects. Took me some time. So then I try to understand what is a template. Can I not do this by a custom template? Of course you can. And this is where templates come in very handy. And they're, of course, documented on GitHub. Let me show you this. Don't blame me. I can at least see the FUF icon. I have sometimes I cannot even see the FUF icon in my tabs bar, right? So there's still space left. So this is create the templates. This is an official TypeScript template, and then they have here. It's worth reading. If you have like 20 minutes time somewhere, and you work with front ends using React and create script and stuff, make sure you check out the template documentation. It's worth. And if you have the same things where you have to add common things to all of your projects from time to time, you can use templates. Or others using GitHub repositories as templates. Like you can git clone an empty and project with a package JSON, all this kind of things in it. Yes, that's also working. Depends on what you want to do. I like this template idea because then I rely on the create React app thing and so let me tell you why I don't like I have a GitHub repository and I do npx create React app once, then I push everything to GitHub and share this with my team and they use the GitHub repository as the template. So they use this for like a couple of months, years, whatever, and then of course they can npm update on their local machines. But if I got new features or different kind of setups in this create React app script that I'm using, this will never be part of this GitHub template because I'm not executing it every time. I'm just doing it once. And an npm update will not fix this whole thing. It will update dependencies, but it will not generate, it will not get new features and structures from this create React app thing. With a template, we are using create React app all the time and adding our custom template at the end. So we make sure if they push some new stuff to create React app, we make use of it, right? So that's why I think a template is a better idea than just sharing a GitHub repository others can consume and pull. And another thing that happened like a lot of times with people using this GitHub idea, I mean, the chance that somebody will override your template on GitHub is nearly by 99%. Because they will not switch. It's like, it's written in the README, of course. It's saying, hey, clone the template, delete the .git directory, and do git init and create your own GitHub repository. If you overread this little sentence, you will do all the stuff. You git push. OK, oops. Sorry, we have accidentally overridden your template. Can you maybe like merge it? Like, can you do it like backwards? Maybe is it possible? Annoying.
So just to understand too, so if I create a custom template and I start a project, and then the author or authors update the template, there's an automated way to bring those updates into an existing project that started with that custom template?
No, that will be executed once. This template will be executed once. But as I said, there's a very, very, very interesting documentation about custom templates and how they work. It's worth it, definitely a read. So here, for example, a template must have the following structure: a README, template JSON, a package, a template, a public source. And this is what I mean. In this source directory, you can put basically in whatever you want. And if you have in source something custom, like your custom TypeScript files, just dump it in source. Or another thing I was doing for a company was like, they set it up a front end, and all the time they were looking for logos and icons and fonts and all this kind of stuff. And of course, we can say just reference them by a CDN, but sometimes it's just super important to have those files locally on your machine. And to me, it's better, and this is another, that's what I was saying always, because I went to this valley of pain 100 of times. If they are not part of it, you just clone the repository real quick, then you pack your laptop in, you go to the airport, and you, on the flight, you make it up, yeah, it's not working, because the font is not there, logo is not there, and you are now 12 hours on the plane, and you're about to do something, and you cannot, because the font is not there, stuff is missing. I could have checked it earlier, yes, but I expected that if I clone this thing, it's everything included. That's why I'm saying just make it part of the template, ship a couple of WAF files, font, images, whatever, so that somebody that spins this thing up can work actually with it. It's not hard. It's a little effort for somebody who's doing it once, but it will help a lot of people just cloning their repository. All right, so this was about React App. That has actually nothing to do with Docker at all, but it's super important. Okay, so then we have now my app 2. My app 2. Jesus, good. So we have node modules, we have README, we have a package JSON, we have public source, tsconfig, whatever. So next thing is basically, if we would like to see what this front end looks like, I see a couple people doing this, npm start. In this case, it works. Another thing I would like to share with you is, in this case, both works. Yep. So this is another question I see from time to time. What are the difference between npm run and start, and what does it mean? What is run? Why not use run when not? Good. npm start in this case is part of the npm ecosystem, and it has some common files it will execute and look for when you just type npm start. If you have some special things like with NodeJS and you have a server and a large project, and you would have the same experience for an engineer and say, hey, if you type npm start, it should work, okay? You can define those things inside of your package JSON, and I recommend you to do that. There's a script section. And you can put as many things in it as you want. Make sure you do it. If you have a Node.js, like a backend API that needs some special arguments, for example, for a node, let me show you this. I've already prepared that. Sorry for jumping around, but this is another thing that is really painful if you not do it. That's why I'm telling you that. So, package JSON. Here. So, if you initialize a new node API using Express, you can type npm init. It will generate a package file for you, and then we simply do Express. Perfect. Let's do that, actually. So you can follow along. So we mk'd here Node.js2, then we do Node.js wrong, Node.js2, and it is empty. All right, so now we do npm init. right? What is the package name, right? This is our awesome API. Of course, version is fine, description, meaningful description, enter. Index is fine, test commit, like, So, good. Now in this package.json, we see there is a main file that's index.js. Good. So that means it will look for index.js in your directory, and when you type npm start, it will check what's the main, in this case index.js, and will execute it. Fine. All right. But if you have some larger setup and you would like to, for example, you have some mock servers and you would like to give the engineers a way to spin up a mock API server, or what was the case with the identity provider. If you have a mock server in your backend API that mocks some sort of servers, and that's a separate NodeJS server, which is definitely possible, then I would put it in the script section. So let's say we have something in source. Then we do, let's call that fake IDP, for example. And in fake IDP, we can build a fake IDP server that is a server.js. Let's first install npm install express. That's the framework we can use to build like APIs using Node.js. So now we have express. So now let's copy Node.js source server.js into fake IDP. Server.js. And this is not really doing anything meaningful. It's basically just using express and then saying get on slash, and then let's say hello from fake IDP, perfect. So, and I can do this. I can say node, fake IDP, server.js. Okay, already in use. Change the address. Let's use something different. Let's use 3999, for example. So now I can say, as an engineer, okay, I can use fake IDP server.js and it will boot up. And then I do curl localhost 3999, and it says hello from fake IDP. Absolutely amazing. Okay, you know that. And you know that it's working like this. So the question is, does another engineer knows that you can spin up this fake backend in a similar way? If not, you can do in the package.json, in scripts, we can just define one here and say IDP, for example. And then you say, okay, I want node fake IDP slash server.js. And if you need some specialties like what port, what environment, some other environment variables, you always specify it in here. You say IDP, node, fakes, whatever. So and then when you do npm run IDP, oh, now it's already running, isn't it? I think we stopped it. Yep, stopped. So it's npm run IDP, and then we're saying, okay, it's working. Again, it's very, very, very small thing to do. just adding it to the package.json, but it will help another engineer to understand what you're actually doing. Right? So put it in for what it's worth. And these are the difference. If we do, it will basically tell you I have no idea what IDP means. But it would know what start means, but it would look for an index.js file because that's what we specified in the package.json. So anytime you need to execute a script, and that's basically what this thing is saying here, if you want to do this from the scripts package.json thing, you have to tell npm that you want to run a custom script, and that is in package.json. So npm run IDP works in this case. Okay? Because I see this question from time to time, what are the difference between npm run start and npm start? For start, nothing. For something you create, it will not work without start or run. Okay? Good. So now we have this API. Amazing. So let's check Node.js and use Docker init in our Node.js 2 thing. So there's no Docker file in it. There's no Docker compose file in it, and now we can create this by ourselves. Or if you would like to get started with something like this, we can use a new command that's called docker init. It's like npm init. And one thing that is important, I'm just hitting enter, it will initialize a Docker project. But one thing that is important when using this, I'm not sure if it's this behavior for all the languages because I haven't tried all the languages. But for Node.js and PHP, thank you. For Node.js and PHP, it is super important that you do the npm init or the composer stuff first and then do the Docker init. If you do it the other way around, for example, if we do Docker init first and then do npm init, it will tell you, hey, there are already a Docker file and stuff in this directory. I can't create new files because I might override things, which is bad. So don't do it. That's why the ordering here matters. Do your npm init first, and then, if you're ready, do the Docker init afterwards. So in this case, we type Docker init, and then we can see, OK. And another thing here, you see, it detected Node.js because there's a package.json in it, and there's like common files in this directory that lead to the expectation that this could be a Node.js project. So Node.js will already on top of this list. Another reason why you should always start with the project code first and then do the Docker init. OK, Node.js is right. Perfect. Enter. What version of Node do you want to use? OK, now look at the version, 25.1. And I will tell you another thing that is super important when working with Docker and engineering in general. Enter which package manager you want to use. That was your question. We can use npm, detected. Perfect. Or we can use yarn, which is another package manager. Please don't ask me which are better. Personal preference. It's like if I ask you if you like green or red. You like green. I like red. Whatever. There's no reason. It's you love red and I green. That's fine. And we can live very, very good next to each other. Yes?
The only question I'm asking is that like we are that much identical that it doesn't matter.
We can have a chat about it at some later time. It's the same question if people ask me, should I use Maven or Gradle? It depends. As always in software engineering, it depends. Whatever you want. There are some things that work better in Gradle than in Maven. There are some things that work better in NPM than in Yarn. For the normal use case, it doesn't matter. For some specialties, it matters. That's why I'm saying it depends. In my case, I'm starting most of the time with NPM. Good. What command do you want to use to start the app? So now it's saying node index.js. OK? If we remember what we did previously in this thing, it was we did not create an index.js file. OK? So actually, let me let me cancel that and do something. We have this fake IDP, which is fine. We have in source. We have something in source. No, it's empty. This is another thing. People try to put an index.js file into this root directory. I don't know. You can't do this. Technically, there's nothing wrong with it. I just don't like it. I don't like to me, this is like, I don't know, an index.js file in the root directory. That's, I don't know. I would feel better if it's in a source directory, something that tells me, hey, there's your source code, and the index.js is part of the source code. Maybe that's my little monk in like for whatever reason, but this is, yeah. Let's create it inside of index.js. And then you can think of, is it index.js? If it's app.js, is it server.js? That's totally up to you. Just make it, index is the index of the project, which is fine. Call it main.js, call it whatever.js. But don't put an index.js file in the root directory for whatever reason. Create a source directory, and I'm fine with index.js, right? So let me actually use the server.js, and I will use index.js, not server. I use server for whatever reason. I don't know why. As it spins up a web server, I use server.js because it's a server. It's like, okay, good. Now we have inside of this directory, we have index.js, and we are in backends, NodeJS, and source. Okay, and if we run now inside of this, the Docker init again, node, fine, yes. So it tells node index.js. And now we have to tell him it's in source index.js. And what port you want to listen on, it was 3999. Good. So, and now it automatically created a Docker ignore file, which should have the node modules in it. It has a Docker file now, and it has a compose.yaml file. The compose.yaml is the new name of the docker-compose YAML. It was docker-compose YAML for a long time, and now it's just compose YAML. So it will work with docker-compose YAML as well, side note, right? But I recognized while using Docker init that Docker now names it compose.yaml. So all the directories I came across, I have created, I'm about to rename things to compose.yaml. I just want to avoid that with some newer compose version, they deprecate docker-compose, and if you not have a compose YAML in your directory, they will not work anymore. Another tip. If you see something like this happen from time to time, make sure you spend at least a minute to think about, hey, why is it now compose.yaml, not Docker compose? Try to research things like that and understand why is it like this. And if they tell you on the website, that's fine. Docker compose and compose YAML are identical, and we are not about to deprecate one of these, fine, keep it. But if they're saying, hey, Docker compose is old, compose is new, and we will deprecate Docker compose in one of the newer versions, make sure you spend some time renaming things, just to make sure it will not fail from some, I don't know, one day after Christmas, just because we have the wrong file name. That would be bad. All right, so now let's check what they did. So Docker compose init created a Docker file, a Docker ignore file, and a compose file. So now let's check what's in Docker ignore. Okay, what is Docker ignore? Docker ignore is similar to what is git ignore. Git ignore prevents specific files or directories from being pushed to the remote repository, right? Clear. Okay. Docker ignore is something that is similar to what Docker build is doing when you have a copy command in your Docker file. In your Docker file, you have copy dot to something inside of my container image. If you do not have some stuff in your, like if there's nothing defined in Docker ignore, it will basically copy everything that's in your directory into your container image. Sometimes you don't want this because a Docker file, here, a Docker compose file, like VS Code, next settings, project, git ignore, like build, whatever stuff is, you don't want to have that in your production image, neither the Docker ignore file, right? So, and this is, when we type now docker build, it will look into this directory and will not copy the files and directories that you mentioned in docker ignore. Reason why I'm saying it, I saw at least 100 times where people are doing copy /source to /source. Then another one, another one, another one, another one, and then 100 files. And I was saying, like, why are you doing it? Because we don't want the Docker file, we don't want git ignore, and we don't want something else. All right, so you wrote 150 lines in your Docker file just because you don't want three files in your image, and you never thought about that there must be a better way of doing it this way? Interesting. Let me tell you what, you can simply use a docker ignore file, put these 3 things in it, delete 150 lines from your Docker file, and just copy / to whatever. It's amazing. If you look in the faces of people when you explain something like this, that's amazing. It's like, are you kidding me? Are you real? Yes, it's real. Yeah, it works. Fine. Okay. Thank you for nothing. That's why I'm saying it. Use docker ignore. Don't put 150 lines in your Docker file. I mean, you can do, but it's not efficient. That's why docker ignore exists. Okay, so that was generated, and now the Docker file. Yes.
Why Docker file has a capital D and everything else is?
Jesus, that is a good question. The question was, why is the Docker file with a capital D and everything else with a lower d? That's interesting. I'm pretty sure we'll find out over the conference. I have no idea. I've never asked myself this question. Now I'm a little bit embarrassed that I have never asked myself the question, why Docker file has a capital D. That's a very good question.
I love your consistency in your lessons learned, and I thought you might have the answer.
I have not the answer to that question, which is, but that's amazing because I will have definitely learned something new at this conference then, because then I know why. I hope we will find an engineer that will tell me why we have a capital D, not a lowercase d. I hope we will find the answer, otherwise I cannot sleep. Jesus. Okay, good point. Good. Now we have a Docker file. All right, it looks a little bit different from Docker files you might see, and this is because, of course, Docker init uses Docker best practices. Makes sense, right? If we have something from Docker that's called Docker init, it would be great if they generate a Docker file that uses best practices. And that's what they do here. So first of all, they put a syntax Docker file in it. This helps Vim, Nano, NVim, whatever, to detect or to understand what is written in this file, because what you can do is you can write your Docker files in a way capital D Docker file dot production dot dev, and sometimes if you don't have this syntax thing mentioned in this Docker file, Vim, for example, will not show nice shiny syntax highlighting because it says, hey, this is not a Docker file, it's a Docker file dot production. Don't know what this is. So that's why from time to time it's important to put this syntax thing in it. It does not do anything with the Docker file, it's just for your editor. Okay? So, and then we have an argument. That is Node version 25.1. Good. Then we have this from, which says node, node version - alpine. Good. So, show of hands. Who in this audience uses in the Docker files in general from something latest? I use that like a million times. It's not a problem.
Isn't that dangerous?
It is dangerous as something. Why is it dangerous? Why you should never, never, ever use latest? Yeah, it will pull the latest. Sorry? Oh, you don't know what I'm talking about? Okay, then I will explain what I'm talking about. If you take one thing out of this lessons, then please stop using from latest. And I explain you why. yeah, for example, right? So I can tell you what, and this happened a couple of times to me, and this is why I'm explaining it. That's the most lessons learned from this session. From, and then node latest. What will it do? Let's use our nice Docker desktop thing and go to images. And you can, or to search, and then search for NodeJS or Node. OK, so we can check this here, or same thing, because I've just learned that we do not have all access to Docker desktop right now. Let's use the Docker Hub then. It's the same thing. Go to Docker Hub, we load it. We type node, node, node. Good. Tags. So tags are like versions we can define for given Docker images. And latest is a good thing, right? Latest, if you use it, then latest is a good thing, because it will always pull down the latest version of a given image from the repository. If you would like to use the latest version with all the updates in it, you can totally use latest. Good, perfect. So, for example, latest was updated 4 days ago. September 29th at 4 p.m. Perfect. So, then we have some other tags. We have slim, which are basically like smaller containers. And then we have current alpine. We have current, alpine, alpine. So this is like this was 2 minutes before the latest one. So that means that maybe, or with high chance, the node version in this latest one is 20.8.0. Agree? Likely. That if we pull down the latest image, it will have 20.8.0 in it. Perfect. Good. So if we use latest in our build image, like in our from here, you run Docker build today, and you will get 20.8.0. You run Docker build 3 weeks, 4 weeks, 6 weeks ahead, you will get maybe 20.9 point something. Or even worse, you will get 21 dot something with a breaking change that all the things you do with 20.8 are not longer working. Nothing, not at all. Like nothing of the stuff you have used before will work with Node 21, maybe. And you will just find out by starting the image, because the build might be fine. It will probably build absolutely fine without any issue, but you push this thing to a production server and it will not work. Or even worse, some parts of your application will work and some parts of your application will not work. But you will not find out by the first hour or the next 2 hours. Sometimes you will find out like hours, days later that something is somehow not working as you expect. Then you're trying investigating and say, why do we have no version 21 in our, like, who tested Node 21 with our application? Nobody. So this is why, if you're doing it locally, you can definitely give latest a try, right, to get the latest version. But the reason why I'm saying it, that's so like, be careful with that and start doing it right from the beginning. Stop working with latest if you're doing stuff. Go to the Docker Hub or to your Docker desktop extension and see what is the latest version, and then define it explicitly. I want to use 20.5.1-alpine. Good. And if Node comes, for whatever reason, to the crazy idea we don't want to ship a Node like an Alpine version anymore, that this build will fail, they have to delete the Alpine image from the repository, but then the build will fail. You will not push anything out to production that is not working anymore. You will recognize it very early in your stack that something is not working well. So that's why this argument from thing here is one of the most important things you should learn to use. Define a version that you want to use. And the Node versions, for example, they come with this tagging, there is probably a version that is called 20.5. Pretty sure there is. They have 20.51, 25.1, 25.1. Here, 25. What does it mean? If you define 25, that means if they push 25.2 tomorrow, you will get 20.5.2 if you use 20.5 in your image. You will get the smaller version updates, right? But you will never go to 20.6. Never. And this is something you have to think about. If you're fine, because not, and this is again, usually it will not break. These smaller version changes from 20.5.1 to 2 should not have breaking changes in it. Should not have breaking changes in it. This is something you can tell your boss why you have to be in the office at 3 a.m. in the morning because, hey, we reverted the image. It's now 25.1 again. What was it before? It was 20.5.2. And yeah, it should not have breaking changes in it, but it had breaking changes in it, so I've reverted it. So it's all working again. OK, perfect. Can we something do that avoids this issue? Yes, we define 20.5.1 the next time, right? So just to get an, like, I saw everything like this. I had problems with versions that were like bumps from 20.5.1 to 2, and it was not working anymore. It was a breaking change, even it was a small one. So that's why I'm saying, be careful when doing this. For what is it useful? When we come to CI/CD pipelines, for example, it is very useful if you have nightly builds of your application running it in some integration tests. Then you can use 20.5, always. Because then you can see, hey, if you have your set of integration tests running at night, and then you can see is 20.5.2 working, or define 20, for example. Is my application working with Node 20 in all major releases they do from 0.5, 0.6, 0.7, 0.8? Perfect. Then define Node 20 in your pipeline and build it every night and do the integration testing with Node 20. Or use latest in the pipeline and try if your application always works with the latest version of Node.js, for what it's worth. You can totally do this. That's why I'm saying I'm not saying that latest is completely wrong always. It can be useful in very, very, very specific cases. For your production builds in your pipeline, latest is not right. For your nightly builds in your integration test pipeline, it is absolutely a nice thing to do. Just to be a little bit ahead of us. We at NGINX, for example, we have pipelines that use like beta versions for PHP, release candidates for Python. We have an application server that's NGINX Unit, and I would like to understand if our implementation of PHP and Python breaks with a future version of PHP or Python. So I use the Docker images they ship with release candidates to test our application server against those versions, just to be a little bit ahead of the development and saying, hey, if they have a breaking change in their Python or PHP 9, for example, which will come out soon, right? I would like to understand if my application server is still compatible with PHP 9. So I use release candidates sometimes in our pipelines as well. Good. So this is super, super important. Good. So then we have workdir. That's basically doing a CD inside of your build process in your container. Normal Linux command, like tell the Docker container, hey, this is my work directory. And anytime you're doing copy here, we'll copy from from the directory your Docker file is currently located, this directory, into dot means into the work directory. If you do not set work directory, it's root /. Okay? So this is another important thing that are not used so often, but it's very powerful when it comes to caching. If your images are small, it doesn't really matter. If your images are bigger and you do a couple of changes in your image, I have to explain you first how that layering works and what happens if you change one layer. So the Docker image, there's a nice picture, and it's too bad I haven't it with me, but you can imagine it's like a sandwich. A Docker container is like a sandwich. You have a slice of bread, which is your base image, and you put a lot of stuff on top of it, like salad and cheese and whatever you like, and onions. And at the very end, if you start up the container, if you type this Docker run thing, you will put the slice of bread on top of it. Anytime you run your container, you will always put another layer on top of it, because all the changes you do in your container, like creating files, changing things, will be represented in this top layer that will be generated when you type Docker run. If you stop the container, this layer is still there. If you remove it, it will be gone. It's not part of the image. It's part of your, it's a runtime thing. It's just on your host. It's not part of the image itself. This is how a container image works with this layered file system. So consider it as a sandwich. Okay, and this if you have a sandwich with 3 layers, like cheese and peppers, like whatever, ham and onions, slice of bread on top, and you don't like cheese, what you cannot do is in Docker, you cannot just pull out cheese. You have to get rid of the onions first, then of tomatoes, then ham. Okay, now it's cheese. Okay, let's put cheese back off the sandwich and now put all this stuff back together, okay? And this happens when you type Docker build as well. If Docker recognizes there's a change in this cheese layer, it has to pull, it will change the cheese layer, but it has to pull back all the other stuff on top of it to make this final sandwich. It cannot say, okay, I'm changing just cheese and all the rest is untouched. I don't care. So this is important when you create your Docker files. If you have a change in a layer, and each command here, like run, copy, expose not, but copy and run is a separate layer in your Docker image. If you do run something, another run something, it will generate layer per layer per layer per layer. That's why you see in most of these Docker files this thing of run, update, end, up install, end, and have a list I can show you what I mean. Let me show you that in our give you a good example here. Packages, Docker, let's see, PHP 8.2. This is what I mean. You say run, and then you chain all those things together, because now it's one layer. You can finally say run HD clone, run CD, run this, but every run command will generate another layer in your Docker file. And every layer comes with a little bit of operational overhead. Not much, but a little bit. And if you have a million layers in your image, this will add 1,000,000 times this little operational overhead to your image. So this is this crazy chain thing you will see in most of the Docker files from bigger vendors. This is the reason why they're doing it, because they want to generate a single layer that has all the components in it. All right? Right. So, and the thing with this layered file system is that anytime we change something in this cheese stack, we have to touch all the layers that come above the cheese stack, right? That's why the caching comes in handy, because it will download basically again, so this is we mount things here, like for example the package JSON log, and then we have here a specific mount, and we cache basically everything that is here in the npm thing. So that makes use of the leverage a cache mount to root npm to speed up subsequent builds, that we can use what we have already created over multiple builds. That says the run user, and then we have here the expose thing. And here you see we made a mistake, or I made a mistake. We typed source index.js, which is not right, because now it's the CMD line of our container will execute source/index.js. We need node space source index.js. I did that wrong at the time we did this Docker init thing, where Docker asked me, hey, what is your startup thing? And it had node in brackets, and I don't know, and this may be a good feedback, because I thought node in brackets means, hey, that is node, and now type what node should do. It's not. It's like a hint. Should it just be node? So let's do node source index.js. All right, so now for development, we can get rid of this one. OK, now we do it. So now we have the Docker file, and now let's have a look inside of, we have like 5 minutes to the next break, so that's something we can do. Let's look here. So we have a couple of comments. And then we have services is the server. We build context is dot. So that means we will look in the current directory for a Docker file, basically. We define an environment variable that is set in the node end to production. And then we expose port 3999 to 3999 in the container. OK? Good. And not touch this one. So now when we do docker compose up build, that's basically what Docker init is saying. It says at the end, run now docker compose up -- build to spin up the project. All right, so now it should work on 3999. Let's see. Curl localhost 3999. Perfect, works. OK, so what have we learned just before the break? Creating basically, to get started with a node-based API, which we can then use in the project in a little bit, is we do first npm init, then we do all the stuff we want, and then at the end, if we want to Dockerize the things, we type docker init, enter, and then it will detect automatically, hey, that's a node project, amazing, node. Then we define the entry point, a couple of other things, we hit enter, and the benefit we get is it will generate a Docker file that is following current best practices. It will generate a Docker compose file that is following current best practices, and it will generate a Docker ignore file not to put everything in the image we probably don't want to. So this is the benefit of what we get when using Docker init. All right. Good. So next would be PHP FPM, and I would like to spend the next 4 minutes to show you the old way, how I used PHP. Who's using PHP in production or still for development? So is it interesting if we do the PHP stuff? Yeah? Good. So, I mean, I'm using PHP since I was 12 years old, so for a very long time. And I still love the language, by the way. It will not convince me not to use PHP anymore because I love the language still. It's, yeah, sorry. I'm not smoking or not drinking, but I love PHP, right? So, good. In PHP, basically, what we cannot do is, we cannot NGINX cannot read PHP code. Even if it's part of this NGINX thing somehow, but we cannot interpret PHP code. We need an interpreter for this one, which is called FPM. The process manager for PHP is one of this. And it implements the server API of PHP. So what we do is we request at NGINX, hey, I would like to see the content or the execution of this PHP script. NGINX will take this script, sends it over to the FPM. FPM will do the PHP work, send back the response to NGINX, and we send it back to the client. Something that's called an FCGI proxy. That's what NGINX is doing in a nutshell by reading PHP code. All right, so, and if you would like to do PHP in Docker, there are a lot of tutorials out there how to do it. One is you can put NGINX and FPM in a single container. But then you will end up with this nice little problem of having multiple processes in a single container. And if there's one thing that is against most of the standards from Docker is that you have multi-process containers. If you're not using something like supervisor or something that will be a single process that will be executed. Now it's blue. OK, but I can talk about it. That's a single process that will be executed and then starts other processes. That's basically what supervisor is doing. OK. Another thing that you see a lot more often is you have two containers. One is NGINX. The other one is the FPM, like the process manager from PHP. Problem with this is that your NGINX must have access to your files, like HTML or index files, whatever. And the PHP FPM also need access to the PHP files. So you're ending up copying things into two different containers at the same time. So let me see if I can fix that by doing the same trick as 1 minute left. Let me see. Nope. Nope. No, it's gone. OK. The screen is already doing a break. OK. So after the break, I will. Oh, now it's back. Yay. After the break, we will look into this setup. And we already did that, basically, because that was the pull we did earlier by using this Docker compose file with the, like, this is NGINX, which depends on FPM. And then we have the FPM container. Does this sound familiar to most of you working with PHP? This like two-tier setup thing. And I have used that for a long time since I have discovered NGINX Unit. And this is what I will show you after the break, how to use NGINX Unit. Because with NGINX Unit, we need just one container that can run 7 different languages in a single server binary and is a web server in a single thing. So we don't need FPM anymore at all. So it's just one thing. And this is something I would like to show you after the break. Perfect. So see you. And I have a slide for this, actually, for the break. Nope. There you go. So 15 minutes. That's what I'm saying. I have not much slides, but I have at least the break slides. All right. So it's 11, the last hour. And it's actually nice that you're still with me. So it's not too boring then. That's good. All right. I have created a GitHub repository. So I can dump all the examples and the PDF, this little Word document I was working on. Here. So yeah, I will finish this one maybe on my way back home. And I have like 12 hours flight. That's perfectly for doing writing like this. So expected this PDF to be in this GitHub repository somewhere the next week, OK? And I will make sure it's including all the examples and stuff. All right. Amazing. Good. Let me make this bigger so you can actually see that. So it's again in my repository. Then it's DockerCon 23-webdev. I can put that maybe in here as well. Let's see. Yep. Yep. So yeah, we'll keep this thing up at the end. So good. So as promised, let's jump in the PHP world then. So dev workshop. Good. So in backends, let's create a simple index PHP file. Like this, right? I don't think we have enough time to generate a full API, but the concept should be it's the same. Okay. So we have source, and in source we can put whatever we want. So let's go back. And yeah, the Docker people are working on an example for Docker init for PHP. There is none at the moment, so we have to do that by ourselves. But let's do something like from NodeJS. Let's copy the Docker file, and let's copy the Docker ignore thing for the moment. Where's Docker ignore thing? Good. Oh. Node.js Docker file. Let's do one by one. Good. Good. We keep this, and we rename this to unit. Oh, actually. Nope. Okay. Good. So we rename this to PHP or unit. So now we would like to know what is the unit version. Right. So we use unit. Then there is 131.0 PHP 8.2. Okay, fine. Okay, put that in. Good. Then we delete this, and then we say this is unit. We don't have this. We can keep the work dir, no worries. Use as app, why not? As this is very simple, we don't have caching right now. We can delete this, do this. So then we copy everything. We expose 8999, should be fine. And here, now we would like to start the unit application server to serve PHP without this FPM stuff. Good. And this is another thing. If you have something like this, a base image, you don't have to put the CMD line in it because your base image already comes with a CMD line, maybe. So therefore, it's sometimes pretty handy to go to the GitHub repository because you click on this. Yeah, it's not showing here. It's not showing you the different layers. So you basically do then. I can show you this here. You can go on hub, or there's sometimes repository. This is the info. Where is the link? So we click here, and then in code we do packaging, and don't be afraid of doing it. It's like most of the time pretty straightforward. Go on Docker, then like PHP 8.2, then scroll on the very bottom, and here it says, okay, this is the CMD line. If you want to use it like this, just don't do anything. You don't even have to specify a CMD line. But in our case, what I would like to do, Unit is an application server from NGINX, and normally it's control API because you can reconfigure it, and that's different to NGINX. You can configure it with an API. So you can send JSON payloads to the server to change what it's doing without reloading anything manually. And in this case, I don't want to have the control API listen on a socket, but I want to listen it on IP and port. The reason why we have it per default to a socket is because of security. We do not have any authentication at the moment built in this control API. That's why we keep it with a socket, because it's then very unlikely that even if you just run it on your production server and not looking into it, what's actually it's doing, it's very unlikely that you expose and port to the internet. So that's why it's a socket. But I don't want to be that this is a socket. So what we do is we copy this whole CMD line, and then we just copy that in here. So in here, we now say no daemon is fine, and then we do, okay, that is 127. Let's do 0.000.9,000. Good. And now I show you a neat trick. We can do this expose thing, fine, and we copy everything we have in user source app, also fine. And I will not use the feature we have in Docker, in Unit for Docker. You can copy a configuration JSON to the Docker entry point D, and it will configure the application server automatically without doing anything manually. But this wouldn't show you how the API works. That's why I'm not doing it this time. You can do this, so add in your Docker file, add a line that copies your config.json into Docker entry point D. No, I'm not doing it this time. You can check the documentation of NGINX Unit, and this will tell you how that works, but we do it manually. So in our Docker file, we do now have one line that says we expose port 8999. That's fine. Perfect. So next step is we can now do Docker build, and the Docker build should copy everything we have in source into, what do we call it? We said it is in user source app. Okay, that is too stupid. So we do I don't like that actually. User share unit. That's much better. Sorry? Oh, you're right. Thank you. That would fail. Perfect. Thank you very much. OK, so good catch. It is unit version. Thank you very much. So we have unit version. We have user share unit. That works. So now when we do Docker build, -t is tagging, so you can define whatever you want to do. So we name it /unit. Unit PHP dot. So now it's here. So when we do Docker images, that looks also awful. So now we do this and do in images. So it says it's unused, it's this size, and basically when you look in here, in the image, you can actually see the CMD line. That's why I'm saying Docker Desktop is most of the time so much more efficient than doing it manually, because it will tell you automatically, hey, that's a CMD line. And while we are here, I will just tell you something about this vulnerability scanning thing, which is also very important, because this is something new to Docker Desktop. We can see what vulnerabilities come with what image or layer in our image. So you can do this as an engineer. You can see, okay, what are the vulnerabilities in this application? Vulnerabilities in a whole, like not just in the image, but if you have known CVEs in the code as well, like in the library, that will be detected as well. Docker Desktop will not find vulnerabilities you write in your code. If you have an SQL injection, something, or a cross-site scripting thing, Docker Desktop cannot find this one, but it will find common vulnerabilities in packages. So in this case, we will see that our image, TypeScript Unit PHP latest, is based on Unit 131 PHP 8.2. This is based on PHP 8 Bullseye, and this is based on Debian 11 Slim. And this is one of the most interesting things I like on Docker Desktop. This is the first time I can see the chain of what base images were used, even on the vendor side. I mean, we are your vendor, we are NGINX, and we say we give your image, but that means we use the official PHP image. And the official PHP image uses the official Debian images. So you can easily spot if there is some clunky, weird base image in your stack saying, okay, what is this? Then you can click on it and you can easily find out what is this base image. Like, what the heck is this thing doing, right? So that's why I'm saying this whole Docker Desktop thing makes it just super easy to get a visual view of your images. And this is the vulnerability view, so we can see we have different vulnerabilities, and where do they come from? Like, they are in the Debian package, Debian, fine. So we are not adding any vulnerabilities by ourselves. They're all coming from the Debian base image, which is this one, right? That helps. If you have a scan in your registry and it tells you have vulnerabilities in your image, it does not tell you in what part of this base images you have this vulnerability. It just says you have vulnerabilities. And here, you can easily find out where those vulnerabilities come from. Okay, so we have this, and now we have this TypeScript Unit thing, which is good. So now what we do is we just start it up. We can do Docker run, and then we can -p, and then we can do, for example, 9999 to 8999, and then we had 9000. Was it 9000? I think so. And with p, we can forward ports from the host into our container. And I'm not sure if we have a networking talk this time here. Let's see. Docker PS. Okay, let's use Docker Desktop. That's more convenient. Okay. Hide all non-running. We have the funny Litcher man. Okay. And we have 2 ports, 9000 and this one. Perfect. So see, this is why Docker Desktop is just amazing. You can see the funny Litcher man, which is our unit PHP container, is running, and we have 2 ports. We have this one and this one. All right, cool. And this 9000 one is the configuration API. Good. All right, so now I show you what you basically just have to do to make PHP work without juggling with multiple containers. So, okay, as said, we have now localhost 9000 is our configuration API in Unit. So, and it already exposes port 80 with our default configuration and should print now a hello world thing. But it's on port 80. Okay, too bad. And this is one thing, there's not an existing solution right now, still. You cannot easily bind now another port to an already running container. Not working. You can do with IP tables and juggle around a lot of, there is not a single solution that works right now. Like saying, okay, we have exposed port 9999 that goes in the container to 8999, but now we recognize it's port 80. Only thing we can do is stop the container, recreate, and now listen on another port. There's no good solution that adds ports to the already already launched container because of the way Docker manages networks and all this IP table stuff. That would be nice if we can expose ports dynamically. Okay. The quick and dirty way is always to do docker rm --force. So now it's like, I don't care if it's running or not. That's it. So docker rm --force will stop the container and delete the container. Make sure that you save everything you put in this last spread slice. Because with this command, it's gone. Okay? Very, very important. So now let's start the Docker container with port 80, actually. Docker, yup. So we keep 99999, and now we do 80. Running, perfect. So that means when we do now localhost 89999, what was it? Oh, it was 9999, okay. 9999. Okay, good. So, two things. We have successfully launched NGINX Unit, perfect. We see the default hello world page, awesome. And we recognize that with -p, we can override literally anything that somebody else defined in this expose command in the Docker file. Okay? Because we defined something to expose port 8999, but we are not using it at all, right? So if you define docker run -p, or in Docker Compose, you use the ports command, or this -ports, you can expose any port from this container. That's your choice, because it's your NUT network. You say -p, this port, independent from what the administrator of this Docker file or the creator put in the Docker file's expose command. Okay? You can always expose any port you want to your host machine with -p. Okay, so now we have 9999, which shows our nice little thing here. But we would like to use PHP and make it easier than just things. All right, good. So let's make that a little bit smaller and configure unit to work on PHP. So we do workspace, DockerCon, dev workshop, backends, PHP. I think PHP unit, is there? Huh. Route, action paths, user share. All right, so this is I've already prepared a configuration. That's nice. This is the JSON configuration for NGINX Unit, and this is all we need to run a PHP application in Docker container. No more FPM, no two containers that are connected to each other. NGINX Unit, one, and then this configuration, and that says we open up a listener on port 80. The route here is, I will show you that in an example in a minute. The NGINX Unit router, that's a very powerful thing, because what we can do is we can inspect every incoming HTTP request and can get all the information on the metadata, like hostname and URIs and arguments and cookies, and make decisions where to send this request to based on quite all the metadata of that request. And this is fundamentally different from NGINX, because NGINX is location-based. Anything that fits well in a location, like /location/something, that works perfectly in NGINX. But if you ever try to map requests by HTTP header or cookie or argument, try to match something that is in an argument inside of an NGINX location. Literally not possible that easy. Because in this location matching in NGINX, you do not have access to arguments. You can write a map or use NJS. That's really annoying. So with NGINX Unit, it's super easy. Because you can put in this routing objects, we have action, good. And next to action, you can put a match block, which is match. And then match is another thing. And then we can do URI, something is test, for example. And if URI matches test, we invoke this action. Or we can put arguments in here. We can put HTTP headers in here. And we have implemented the NGINX JavaScript runtime to Unit as well. So we can even define here template literals in this block, and can invoke a JavaScript function to do very fancy stuff with matching, like regex and like whatever you can think of. Like really, that's just super amazing. And yeah, I'm just afraid that it's like we already had 4 hours. That is crazy. And I could tell you for another 4 hours. That's cool. So we stick with the action and say pass it to the application PHP. So then we have a thing that, let's call that app, for example. And then here we say, OK, that is applications app. And the type is PHP. The root is user share unit. And then we can do, OK, the index is index.php. Done. OK, perfect. So, and as NGINX Unit implements the server API for PHP and the API of 8 different other languages, you can run Ruby applications in Java and Perl and Python and PHP and WebAssembly since a couple of weeks natively on Unit. So it's just in a single container. NodeJS, for example, as well, and you can share static files. And I hope I can show you that in the next 30 minutes so that we can see how easy that is. Because this makes it very efficient to work with images because you have a single server binary or a single container image that can do a lot of things for you. OK, so we write that, and now we try to send it. And there is a unit CLI we can use, or we can, I have a typo again. I have a typo again. Oh. Here's a missing comma. Let's see. Thank you. Let's do cat config my friend JQ. All right, that's what I mean. Always. Where is it? Okay, we have passed. This is the action. Oh, yeah, there was a, OK. This was needed, but I've deleted the, yeah, it needs the action, the object here. All right, that's far better. OK, amazing. Good. So that works. So now we can send it over. Like we cat config JSON, then we pipe it to curl -d-to localhost. What is it? 99. Jesus, can't even remember what ports I've used. 9,000. 9,000. Oh, I'm sorry. You're using put, not put. We need put. So x is put. All right. Good. Jet lag kicking in. All right, what we do here is, you see I love working with the Linux command line. We cat config JSON and pipe the output to curl and send it with this add minus, like the stream we had from the first command, we just send it over to curl. You can use curl-x put-d for binary data, and then you define a file name. That's also possible. But if you want to do some fancy stuff before that, you can use this pipe thing to just send it over. OK, good. So we have reconfigured unit, and now let me see. All right, saying 404. That's because I think I have copied the index PHP file into a wrong location, but that's something we can easily find out because we can use docker exec. Or let me show you another thing in Docker Desktop that's super awesome. You can click on that, and you have bind mounts. Nope, files. Yep. So. And this shows you what files were modified during the container is up and running. And we have user, I think, and then we had share, and then we had unit. So see, we don't even need exec. We can use this little neat file browser. Unit, there's a Docker file in it, but I think we had it in source. Where did we copy the files, actually? then I think this is, yeah, then you can, if it's a real file, you can actually edit it. But now we do containers, Sleepy Galileo, exec. All right. Print work directory is user share unit, and I think let's do source. There's the index.php. So it's user share unit source and then index.php. And I think that's wrong though. So I think we have the wrong path in here. Yes, it's just user share unit, and then we need source. But this way, I can show you how this dynamic reconfiguration works. So we just send it to the config API. We're not reloading anything, and it just works. Even that I have a parsing error because of double-quoted string in my PHP file, which is another problem. But this is now something we can fix in Docker Desktop as well. So we go to Files, and then, but just, we are now working in this last bread slice, right? So if we remove the container, the changes we do right now are gone, right? Just make sure that if you test something here, that you move it back to your host machine. Otherwise, it will be gone. So it was share, user, share, user share NGINX. Okay, now I will submit a feature request. I would like to have a text input here where I can navigate to the things. Okay. Now we do it. What's the container ID? 3F3. 3F3. Then we do bin bash, right? Then we in source. Amazing. I thought we have Vim, but it's not a problem. And this is what you can do actually with your LDAP stuff. You jump in the container while it's running where you have problems, and then you do update. Because everything you do now is you're putting this in the top slice of this sandwich. So it doesn't matter. If you restart the container, remove it, and recreate it, it's all gone. So you don't screw up with any of your official images. You're just playing around. That's basically what we're doing as well. Now let's install Vim. Another thing is we can now fix the index on. We can fix the index on our machine and then just rebuild the image. That works as well. But let's fix it inside of the container actually. All right, no, that's slow. We don't do this. We don't do this, okay. Oops. There you go. Build it. And as the config file is not part of the, we can do it. Let's do that. php/docker file into php unit. So here we copy everything that is in. Well, let's then do php source. Source, then we move the index to sort. Thank you. Now we move whatever that is into index PHP. Holy cow. Then we move the index PHP back to source. Okay, that works. Perfect. Now we check if it's correct. It says echo, which is fine. Good. So now we have the config JSON pipe to JQ, because now I can show you this Docker entry point D thing. Because now if we would build it and start it up, it would be empty. So we would see the hello world page, which is not really useful. So what we can do is we can vim the Docker file, and we copy everything that is in here. And yeah, one thing that is now super important. That means we would have the config JSON inside of the source thing, which is sometimes not really useful. I would then do, in this case, because if you put it in the Docker ignore file, it will not copy it anyway to the container, right? It will just not be there. So what you can do is basically a 2-layered build, like one directory that configures the container if you have something like this, and the other one is just copying the data in it. You know what I mean? You have like a multi-stage build. One is using NGINX Unit, and then you copy it to the container, and the other one is just copying source into the container, and not the rest. But yeah, or in this case, what we can do is Docker file, and then we do, okay, we do not copy everything. We say, okay, anything that is in source goes into dot, and then we copy config JSON, goes to docker-entry.d. Right. Good. So this is new, Docker Scout Quick View. It's like that will scan it for vulnerabilities as well. So if you build an image and type Docker Scout Quick View, it will just take some time because it loads data from the internet of CVEs. This will show you a nice little graph how many high, low, medium vulnerabilities you have in this image. Pretty neat. It's similar what you have in Docker Desktop, but this will also work in your CI and CD pipelines. You can use Docker Scout in your CI/CD pipelines. Because Docker Desktop is something you cannot use in your pipelines, but Docker Scout is something you can use. Good, now we have built the image. So now let's run it again. Okay, it's still there. Container, where is it? Delete forever. Okay, this 500 is now because of we have changed the path, we have not modified the configuration, so now unit cannot find the index.php file and will fail, right? So, because we have now, we copy source, so it will now be unit share unit source, which is wrong. So we do this. Then try it again. And if it still fails, then I can show you. Now it works. What could we have done before? It fails with an HTTP 500, exits the container. Okay, so that means we do not specify anything specific, but something fails while starting. What we can do then is we can start the container using an alternative entry point. Does mean Docker run something, and at the end, -bin bash. That will not execute the CMD line, but we have an interactive shell in the container. Then we can execute the CMD line manually by hand by just copying what we have, like unit D, control. It will fail, but then we can go in the container and do is it clear? Should I show how that works? It's clear, isn't it? Okay, let me show you how that works literally. It's really simple and it's super helpful. So it fails for whatever reason, right? And we think there is some, and it's not even booting up. It's not starting. So this is very important. So we do unit, share, unit, and then 1, 2, 3. And this directory does not exist. But this is a runtime thing. It's not on build time. It's on runtime. So Docker will just build the container fine. And then when we run it, so it will say HTTP response code is 500, and see, it's gone. It's not even started. So how to find now the problem? Now we define an alternative entry point and say, you know what? Do not start unit, but just give me an interactive thing, which has been bash, and then you have to put -it in front of it to have this interactive TDI. Enter, and we're in the container. Because bash is there, so it can start. Okay? So now, when we look into, okay, where's our configuration file? It was inside of Docker, what was it? Entry point D, oh, there's a config.json. Okay, fine, there's the config, it's in. And then we must look into the base image, what it's actually doing, and it's normally running this Docker entry point sh script. No matter where that is. It is somewhere. Somewhere is a Docker sh script, and that runs the configuration that is in here. So that means when we do unit D, so that starts up just fine, right? And now if we then try to apply the configuration, we will see the same error, but then we will see, hey, there is the wrong user share unit. Oh, it's without source. It's just an index. Okay, right? So we can go in the container, see why is it failing, and then see, okay, it's in user share unit is the thing, and there's the index PHP. Okay, let's see. It's just user share unit without anything else. And in this, we have the index PHP. Let's try this. Let's build it again, run it again, and it works. So this trick here is very neat when you have a problem in your created image and it's not even starting up, but you have to debug why is it failing. Just bashing in, do this stuff manually and see why. And especially handy when you do copy commands, copy files from somewhere into your container and it's not working because of some reasons. And most of the time, it's literally something like this. You copy source from to something, and there's a slash in your Docker file so that you're not copying the whole directory, but just the files, and then it's not starting. Don't bang your head against the wall. Just doing bin bash, go inside, check if it's there, fix it, easy. Not a big problem. All right, let's start this up again. Start it, perfect, and now, let me see. See what did we containers app started, initial configuration is complete. So we have config, port 80 goes to routes, routes goes to app, and app is doing type PHP, user share unit, and then we do have index PHP. Why is it saying connection reset? Okay, that is important. That's interesting. That's the demo gods. They're leaving us. User share. Well, I'll fix that real quick. User share. That is index.php, which should work. Run, let's do background. Something's not working anymore. This is actually the most important part for me for the demo, and that is not working. Oh, Jesus. I'm using the wrong port. See? It was 80 and not 9C8. Yes. We should use a It's like, yeah, technology is amazing. If the TCP can connect to the port that actually is open, then it simply works. I mean, that's amazing. Great. So we see hello world, which now comes from PHP. Network, reload, localhost. It's actually hard to see when it's like zoomed in like this. It says unit 131.0, and we have PHP 8.2.11. And that's all you have to do. No more PHP juggling stuff. It's unit as the base image, the JSON file, and that's it, right? So now we can fix this favicon thing, because that's always annoying. It says fav icon is not working. So if we reconfigure unit on the fly, and we define a config JSON, and in the router, let me see if I can do this on the fly, actually. We do match, and then we want match of URI is fav icon.ico, isn't it? Yep. Right, if the URI is fav icon.uri, then we would like to invoke an action that says return 200. And then we do the action. Okay, let's cut config in JQ. Again, we have match is URI. I use nvim config. Okay, we have match URI. Oh, match. No, we have match and then action. That should be an object. And then we return. See, that's why I'm normally using the CLI, because writing serialized code is not nice. Okay, so now we do the curl thing with catting and stuff and put that in. Reconfiguration done. Amazing. Delete it. Disable cache. Where is it? Where is disable cache? Can't even see when it's like this. Disable cache. There you go. Why is it not using fav icon anymore? Hello? Right, incognito mode. If this is not working, I'll use curl. Curl will do it, always. Localhost 999, network. Send it. Okay, we'll use curl then. So when we now do curl, it says hello world, fine. EV, it's 200, and now when we do fav icon.ico, still prints for phone not found. Amazing. Okay. So that means the match here is somehow not correct. Is that right? Fav icon.ico. Last test. This is not working, then I'm not sure if it's part of the URI or if it's part of the. It's actually not an argument, I think. Fav icon. Okay, that works. Good, Steve. So it's now it's giving 200. Okay. So that's the interesting stuff you can do with the unit router. You can simply say, okay, do it. That's why I love NGINX Unit, to do stuff like this, because it becomes part of your application. And this is pretty simple and pretty easy, but you can do the same thing for very complex things as well. And we have on the website, we have documentation about like using Laravel or Cake PHP and how to configure it probably. And probably that's great. Cool. So it's like 10 minutes to go. Good, so we have now created a PHP API, very simple, using NGINX Unit. We have a Node.js API, which uses Express. And we have a bunch of Docker containers right now. We have one for the Node.js API. We have one for the PHP API. And yes, that works. We have the front end. All right, so and the front end is now something. That's something usually you build as static files, right? You use HTML for that, and then you need a web server. You can run this on NGINX Unit as well, if you want. Or you dump it in NGINX with this configuration, using the try files command, right? That's special for React. If you have a React router, then you have to use try files. And then you can do npm build here, for example. And then it just builds your React application. Oops, that's a script. Good, right. So, and then you have the build output, and then you can copy the build into another container. So now, as we have just 10 minutes left, and I really would like to cover at least a couple of more things. We have Docker Compose Watch. I completely missed right now, which is a bummer. And we have multi-stage build. Is there anything you're interested right now that we do the next 10 minutes? Multi-stage build, or Docker Compose Watch? Docker Compose Watch is something new. Watch? Okay, now let's do Watch. In Docker Compose build, I make a promise in my notes. I will put it in this PDF document, how multi-stage build work and how you can use it to have like a local build pipeline, a mini pipeline on your computer, laptop, just to use it with multi-stage build. Promise. Because what you can do is, one word, you can use Node as a base image for this React application, then copy everything from the source directory in the Node thing, set it in the Docker file as a build image, then run npm build, and just copy the build output in an NGINX container, and then that's it. But you don't have to have Node on your system to build your application. So if you pull down and type Docker Compose build, it will just build your project, and you don't have to have Node on your system. Okay, that's why multi-stage builds are always super, super important. But let's do Docker Compose Watch real quick. So Docker Compose Watch, and I have actually a slide for that. So excellent choice. So what is Docker Compose Watch versus the bind mount we already? Okay, that's too fast. I have to do it slower. Okay. Wait. Okay, again. Nope. Let's see. Yes, perfect. Okay, what is Docker Compose Watch? Docker Compose Watch has two different modes. One is sync, and the other one is build. So what it does is basically on sync mode is it will detect local file changes from a given file, and then it will create a physical copy of that file and sends the physical copy of that file into the container. So it will not use the files you have on your system. It will copy them into the container. That is handy, because if you do stuff in the container then with Docker exec, because you would like to try something different with node modules or whatever, it will never copy stuff back to your system. Never, never, ever. So, and this is the problem with the bind mounts. If you mount like a directory from your computer, software, like laptop, whatever, into a container, and you do something in the container, it will automatically sync between your client and the container. And this sometimes is very, very dangerous. For example, if you have a caching folder, you have a Node version, 25.1 on your system and you're launching it with 25.3 because you would like to do some testings, and then you run npm install in your container, it will override whatever on your node modules folder locally on your machine. That results in a non-working thing, maybe. So that's why. Bind mount will be synced, always, ever, because it's not a copy. It's like a physical mount of files in your container. With Docker Compose Watch, it will create a physical copy of that file, send it to the container, so it will never sync back. So let's have a look how that looks like actually in production or on the command line. Let's see. Yes. Good. All right, so in workspace, Docker Web Workshop, in backends, Node.js, Vim Docker Compose Watch. Let me see, and Vim Compose. Yes, so you can use develop and watch, and then we have action. And the action can either be, let me make this a little bit bigger, the action can either be rebuild or sync. Sync will just copy the data, not rebuild the container. So if you just want to copy data for PHP, for example, you don't have to hot reload or build the image, because PHP will read the file, interpret the file, send the output. For Node.js, for example, if you already started the container using Node, fake backend, whatever JS, hit enter, you cannot modify this apps.js file without reloading the Node process, because it will not hot reload files from that server. So in this case, we define action as rebuild, and anything that is in source that goes to user source app source will trigger this rebuild. And we will, of course, ignore node modules. So that's how you define it. And now let me show you how that looks like. Then we do Docker Compose Watch. Did I screw up anything? Then Docker Compose. What is wrong? I think I've changed something and now it's not working. That is bad. Let me do. We have action is rebuild, anything that's source, it's that target, and we build this. Let's remove this. What is an app? Nothing. Right, remove it. Node modules package, Docker file. What is in source server.js, source server.js, 3100. Let me just kill everything really quick. Go away. Like, nope, no. Just want to make sure we have. Okay. Oh, now I can show you my favorite command. Docker, that's like weekend transaction. Docker rm -- force, I'm just kidding, that's very dangerous. And then type $docker ps -q, enter, and it will literally take just the IDs and send it straight to rm force. It will delete everything. So now it's clean. See? Blank. Just kidding. Don't do this in. So Docker. I mean, you can do it with a lot of other Docker commands as well. But if I'm done with some stuff and I want to clean up my system, Docker rm -- force $docker psq is absolutely amazing. All right. So now it's all gone. Now I'll try to build this thing again. Node version, production, run, copy, expose, npm run start. When did I change this? I've tested it this morning and it worked. Server is not internal. Okay. Oh, okay. Let me remove the caching real quick. I think we have screwed up something with that, and we don't have enough time to fix it. It's still not working. All right. That's a bummer. That was the most important thing, by the way. Almost. Yeah, basically, it's like then you change the file, it will trigger a rebuild. I know we are over time, and then they will actually kill me if I'm running over time. But let me quickly fix that real quick. Node.js. Trying to fix it real quick. Node.js 2, RMRF, fake backend. Was this working, by the way? I think that worked. Okay, then the Docker Compose watch is working as well. So this works, finally, perfect. So then let's do it here. That's the other app we have created here. So let's do it. Okay, Docker Compose watch. It has no Docker Compose things in it. Okay, fine. Node.js Compose. I'll just copy that real quick. Copy. Paste that in. Okay, still working, fine. All right, so now let's do the Docker Compose watch thing. I don't know what's wrong with the other project. But now it should work. Docker Compose watch. No, okay, now it works. So now it says it's watching Node.js source. And when we open up another window, I know it's small, but it's not really interesting what it says. So now I'm navigating to backends and then Node.js 2. And in source, we have index.js. Oh, I already saw what happened. So now it's saying that is 3999. That should print hello from server. Amazing. So now we change that and say hello from compose watch. Compose watch. We save it. Now look what's happening here on the left side. It detects that we have changed the index.js file. And now it's basically automatically regenerating and rebuilding the Docker container. It will automatically boot it up and says hello from compose watch. So you don't have to do this step manually then. You change files and Docker will automatically detect changes, copying it into the container and kicks off the rebuild. Pretty handy. So you don't have to do that by yourself. Right? So that was Docker Compose watch. And it has two interfaces. One is sync and the other one is rebuild. Perfect. Just 4 minutes, amazing. If you have now any questions, I think I will be around anyway, so we can close the official part, and then I will be around for as many questions as you have. I will show you the SSL NGINX stuff. I'm promised. Will do. Right. Any questions? Yeah. it's in this case, if you have the question was, what's the benefit of doing the Docker Compose watch instead of doing npm watch? For development purpose, sometimes something like the npm watch could be more efficient than the Compose watch, the Compose rebuild thing. As said, it depends, right? It depends. In my case, I'm most of the time using sync. I'm using rebuild for things where Node, something like watch in Node is not possible. For things like when I have a mock database, for example, and I have an SQL file, and I edit the SQL file in my repository, save it, I create automatically a rebuilded version of my database with all the new SQL stuff in it. That's handy when you don't have something like npm watch. That's what I'm saying. Maybe Node is maybe here not the best example for rebuild, but I'm using it most of the time for database stuff. When I change things in SQL file and I want to have a newer version of the database, I don't want to have to kick this off manually. And that's cool because it's a no-brainer. You have it you have the database, like dump SQL in your project directory. You need some other files. You just edit manually the SQL stuff. You save it, and it will kick off the rebuild automatically somewhere in the background without you notice. You just have a new version of the database up and running, and that is super important and super easy. Any more questions? If not, I think we can close the official thing then, looking into the jury, the things, right? Yeah? So then there are no more questions for the official part. I think we can call it a session then. This is the GitHub repository, DockerCon 23 web dev. I will put all the examples to that, and I will work on this nice little Word doc PDF thing where I mention all the things. So you can check out the repository. Then just would like to say my last slide is thank you, I guess. It is? Yep, it is thank you. Thank you very much.